Ladies and gentlemen, please welcome back to the stage, Colin Sutherland.
Day 2 GEOTAB Connect in the house. We had a great day 1. Hey Mo, how are you? We had a great day 1. It was fantastic. It was amazing. Last night on Lake Ontario, we couldn't have asked for better weather. I know in the program it says I'm going to give you conference updates, and there are a couple of operational updates on the agenda today. Oh, wait a second, there aren't any updates because the agenda has been gone perfectly. The organization is fantastic. Congratulations to Skyline Metro Connections, Ella, and the entire GEOTAB marketing team and planning team. Thank you so much. Unbelievable. Unbelievable. The coordination of this event is actually mind-numbing, to be honest, but I'm really proud of the effort that everyone has put into it, including your attendance, really coming in from really around the planet, as I said yesterday. So yesterday we talked about business disruption. And you know, again, it wasn't doom and gloom. In fact, I said yesterday, let's embrace the concept of disruption. If you can be comfortable with the idea that disruption is actually a good thing because you can sometimes profit, or if you know where the disruption is likely to happen, you can then go and develop workarounds. You can embrace it. You can create that as part of your business plan, and you too can become a disruptor. A little shout out to Carvana. I don't know if I think one person from Carvana is still here. Have you seen this Carvana commercial on Fox or on TV, on CNN? Oh my God, right? So I'm Canadian, we don't get fun stuff like Carvana. You can, it's unbelievable. Have you seen this thing? You go online and you buy a car, strictly buying cars online, only used cars, not brand new cars. Fantastic. When you buy your car, you can choose to have it delivered, or you can choose to pick it up at essentially a gumball machine for cars. Essentially that, right? You get mailed a coin, and you go to this location, you put your coin in the machine, coin drops down, and your car spins down from this glass tower and rolls out in front of you, and you pick up your car and you drive it away. And if you don't like it, you return it back in 7 days, you're done. Unbelievable disruption. Imagine the little footprint of land it takes for them to build this massive gumball machine for cars, and how smart that is. What a disruptor they are being. And I think they were telling me at Carvana that next to Amazon stock, Carvana is right next to them, and then Wayfair and some of the other online sellers. So they are doing something unique in the area of selling used cars. It's unbelievable, and we're really happy that even in our ecosystem, we can bring together partners and customers like Carvana, who are also trying to figure out how they navigate to continue to disrupt. And I think that that's the inspiration that we hopefully bring to all of you here today. So yesterday was business and business disruptors. Today, GEOTAB by numbers. Really is all about the data today. We've got some great keynote speeches lined up for you, and we're really excited about it. Let me just go over here and grab my clicker. Somebody was wearing this, I forget which country I was in. If you follow me on Twitter or LinkedIn, you'll probably get a little bit of whiplash, right? So sometimes it's like back and forth over 3 days from California to Rome and so on. And they said, Colin, why are you wearing 2 things? I don't understand. If it was Telefonica, our friends from Telefonica, why are you wearing 2 things? Well, you got to calibrate, right? It's about benchmarking. I'm benchmarking my Garmin Vivo versus my Apple Watch to see who is more accurate. And I do that. I count my steps on this. I completely cheat. I like to drum in a band, and I practice drumming. So I get way more steps with my right arm than I do with my left, because you get the hi-hat and you just snare, right? So it's 10 times this, 1 times that. It's great stuff. So GEOTAB by numbers is really what we're going to be talking about today. And I do believe in benchmarking calibration, and you're going to learn a lot about that today with the presentations from both Neil Cawse, Mike Branch, and then Geoffrey Hinton from Google AI's group that'll be joining us later on in a few hours' time. So Neil mentioned yesterday that we hit this really amazing number as a company in February, and since February when we announced we went over 1 million, we've again plussed it, right? So we're a couple 100,000 north now of that number. So how do you deal with that number? You need to figure out how to grow a business based on breaking things down into smaller bits and pieces. The big number that Neil announced, 1.2 million vehicles, has to be broken down into smaller clusters. And for us at GEOTAB, it's our team. We have to figure out, what does our team look like? How do you forecast growth? How do you organize your teams for growth? 2 years ago, we figured out we were going to have this growth. We actually planned for it. But we had to organize ourselves around our planned growth as a company. And we saw that. How would you develop that in your own company culture? How do you go about doing that? So mosaics do reveal a really big image, but you've got to get into the detail in order to go and figure out what's truly happening. So GeoTab by numbers has over 400 people today. A couple of years ago, we had 200 people. So we've doubled our people. It's pretty amazing. Teams include, back then, about 2016 when we started, about those 200 people. I think we had 8 core teams at GeoTab. That was going to expand. So in order to expand, we didn't expand the 8 teams and make them all bigger. We created 15 teams. We broke them into smaller component bits, and then we started to expand our teams out. You've got to be able to do that. You just can't look at things at a macro number and say, I'm going to grow. So you grow your teams by an exponential number. As you grow, you've got to break things down and make it more consumable. It's the way to do it. You've got to be able to do it like that. So GeoTab, now we have software development, automotive engineering. Data science is a new team that we just established with Mike Branch about 2 years ago. Sales and marketing has always been awesome team that organizes things like this. Operations, legal department, human resources, customer support. A couple of years ago, we opened up our big customer support operation in Las Vegas, right? And even inside Las Vegas, there's a retention team that's trying to help customers stay engaged with our product, as well as helping help desk and live chat. We've had to grow that operation exponentially as well. Our teams are codependent on each other. We couldn't be successful as an organization unless we relied on each other at an integral level. This isn't one team in a silo and another team in a silo. We have got to be codependent, just like in a big mosaic, right? So when the big picture and we expand back out again, we can see what we're trying to achieve as an organization. And I think some of the culture in GeoTab that we've established has been reflected in some awards. And we're not an awards-driven company. Awards are nice to receive. But we were really excited in Canada to receive the award called Canada's Best Managed Companies. It's a bit of a prestigious award. Apparently nobody wins it on the first shot. We applied and we won it on the first shot this year. So we just received that award a couple of years ago, reflecting our company culture. So it's neat that we get recognition, not for the sales or the revenue, because we're not publicly traded. So Dow Jones doesn't care about GeoTab, and financial analysts don't care about GeoTab because we're not a publicly traded company, right? It's hard for us to be benchmarked against other companies like ours that are publicly traded. All their capital is out there in the open area for them to be measured and benchmarked against. We benchmark ourselves against those organizations. Plus, it's just nice to be reflected, I think, in terms of our company's management structure and our company culture, which some of you commented to me last night is reflected with all of the blue shirts at the back of the room. It's really nice to hear that you understand that, and actually the consistency of our employees, the enthusiasm of Team GeoTab is reflected. And, you're all part of that culture too. So it's not a GeoTab culture and a customer culture. You're all included in our family. We consider you part of our culture, and we want to have you feel part of that family and part of that opportunity to be part of this family. So one that we're particularly proud of, though, was the second award that we received for a great place to work. And inside that, they recognized the place to work at GeoTab for women. And we think this is a really important thing for us, especially as a science, technology, engineering, and maths organization, that we recognize women in our workplace. And I really wanted to invite and take this opportunity to speak to you in front of you this morning. But what I really wanted to do was to invite a couple of our STEM employees, Sabina Martin from Solutions Engineering, Emilie Corcoran from Security Team, and please welcome Emilie and Sabina on stage, and they're going to tell you their STEM story.
Good morning, everyone.
Hi there. Who here remembers looking down at a math problem, maybe in school, and thinking, when is this ever going to apply to real life?
Growing up, we all knew what a teacher, doctor, fireman, or policeman did on a day-to-day basis, but I didn't really fully understand what a mathematician or an engineer did from a day-to-day until I was much older. In typical education environments, you're not taught how that math problem that you're trying to solve actually applies to career opportunities.
This brings us back to the problem where there is a lack of diversity in STEM. Applying or investing in STEM is actually quite important for businesses in the future.
STEM refers to any program that involves science, technology, engineering, or mathematics. The main reason why it's so misunderstood is because it's not tied to one particular career or role. It builds a foundation full of essential skills which can lead you anywhere, and it's important that we educate our youth about this.
To throw a couple stats at you, right now in the entire workforce, we're looking at about 6% of all jobs being STEM related. That's actually quite surprising considering technology is the center of our lives.
And out of those STEM employees, only 24% are female. And out of STEM students who are in STEM programs, only 23% are female.
Extending those stats, applying to GEOTAB, about 11% of all GEOTAB STEM jobs are women's. See, this is not a great stat, but we want it to be transparent today because that's something that we're continuously working to grow.
We're not saying to go out there and hire a female or someone from a diverse background just because it's going to improve your stats. You always want to hire the person who's best for the job. But we want to address the root issue, which is making sure there's equal opportunity for every young person to have access to STEM education, whether or not they're just planning to be in a technical role long term.
So with that being said, we need to attack the root problem. We need to let youth understand the potential that comes out of STEM-related field jobs. Let's get that curiosity going and drive interest from a young age for all types of individuals.
Traditional jobs today are being replaced by automation, and we don't know what the future holds. It's important that we develop these transferable skill sets for our youth. Things like problem solving, creativity, brainstorm, critical thinking, and leadership are going to be essential for them to be successful in anything that they do.
So what's pretty great is that GEOTAB does recognize this gap. They're already working to improve and build and invest into getting that more diverse STEM environment. Things such as summer internship, research and development programs, and even looking at developing mentorship opportunities for youth to drive that curiosity are already in the works at GEOTAB.
Personally, I chose engineering because I had a passion for art and science growing up, but really I took a risk taking it. It wasn't until I was in university and I attended different conferences, and there was a female engineer who mentored me. She actually moved into the business aspect of her organization, and it opened my eyes to what possibilities are out there. I started in engineering support, which was a more STEM-related technical role. I've moved into solutions engineering, which is a hybrid role that allows me to work with pre-sales opportunities and use those skills in different ways. I'm not always doing something technical, but it helps me to be open-minded and approach a problem from a different perspective.
Sometimes all you need is a mentor to push you in the right direction. Just like Sabina, I liked science, I liked math, but engineering wasn't really part of my vocabulary until much too late. I was pretty lucky that I was mentored and pushed towards this field, as today I'm a cybersecurity engineer, and I get to use those critical thinking, teamwork, and leadership skills today on a daily basis.
Yeah. So to wrap up, in the end, it's really important that as leaders in the industry of technology that we're preparing to shape our youth for the future to come. Having different perspectives is going to allow us to solve the problems that are yet to come in a more efficient manner. We're going to have more ways to think about things, and overall, it will be more successful.
So to give you guys just a quick lessons learned, we're not saying to just go higher to make those stats a little bit more balanced. We're saying that you, as a business, should go and invest into opportunities to mentor youth and get everybody educated towards what the STEM environment can provide.
GEOTAB has been a wonderful place to work and continues to support these programs, and we hope that you will too. We wanted to thank Colin and GEOTAB for the time for talking today, and we hope we taught you something valuable and you understand what STEM needs and weren't distracted by the large pictures behind us. So thank you again for your time.
Thank you.
Thank you so much, Emilie. That was great. Fantastic. That was fantastic. Thank you so much. So believe it or not, May 2016, our number of subscribers was 488,872 2 years ago, almost precisely. It's amazing, right? So 488,872. And we questioned ourselves. We said, you know what? Again, we have a couple hundred employees. We've got 488. We were tracking our number, we were tracking our sales momentum, and we felt something was happening. A couple of things we knew was going to happen in 2017. The truck ELD mandate in America was going to happen. We thought 1.2 million trucks are going to have technology installed in them by the end of next year, 2017. Wow, this is going to be amazing. We're going to hit a big number. We actually forecasted pretty conservatively, a number pretty low, and we did not hit that number, just by the way. So we forecasted about 200,000 devices by end of last year in the truck ELD. And if you're an American and you are following that industry, the truck drivers themselves hated the mandate, and they actually postponed it to April. So in our number that we reported, the 1.2 million devices that we've got now, a very small fraction of that is trucks. So some of you might say, oh, 1.2 million, no problem. GEOTAB had 500,000 truck ELD subscribers. That's how they got. No, we didn't get that way. We managed our team in this one big pie. We had 488,000 devices. We had a sales team of approximately 15 partner managers that managed a pool of partners, I think there were about 120 of them in total. You were all in one big bucket. We managed you equally on a priority basis. We treated you all the same. We do treat all of our partners the same, but we didn't really break you down into smaller component bits to figure out how do our partners sell, how do our partners engage with their customer base. And in order for us to be successful, we realized we had to do that. We wanted to scale, we wanted to employ more employees at GEOTAB, but we just didn't want to continue to expand our employee base in that one big pie, like I said before. So it's an industry, by the way, and we talk about this, our industry, and how our industry scores ourselves. Our industry is scoring GEOTAB on the total number of subscriptions. That's kind of a ranking. How big are you in the company? Right now we're ranked number 2 in the world. Hope to be number 1 in the world by the end of next year, which is our company goal. Again, but in order for us to figure out what we had to do, we had to create unique teams. We created 6 unique teams. One of our partner channels became data-focused enterprise people. So people that were focused on APIs and integrating our back end into our applications into their front end. We had fleet management partners. We love the fleet leasing and the fleet management industry globally. We think it's a strong place for the fleet, for our technology. We love the fleet focus in that industry on how to keep vehicles up and reliable and customers safe on the road. We like small fleet resellers, so fleets that are 25 and under. Fleet management companies typically don't address that market. So why would I treat a small fleet reseller who's targeting fleets 25 and under exactly the same in terms of learning tools and marketing promotions and support the same way that I would treat a fleet management company that typically looks at fleets 100 and up. Value-added resellers. We have SDK experts among our ecosystem that use all of the tools that we provide, IOXs and SDK and data.utab.com. I think they're all excited about the next session to see how they're going to go and leverage that tool and bring that in terms of their go-to-market strategy. We have my GEOTAB-focused resellers, people that literally take the products exactly as we produce them and then resell, implement, and support the product exactly as we build it. So they don't add the IOXs and stuff, and that's okay. That's those resellers. And then we have our truck ELD-focused resellers. So we had to naturally group them together. In addition, we created a business development team that we didn't have in 2016. So we separated business development from support, account management support. We said we need OEM partnerships, automotive and truck. Proud to say that we have a relationship with Volvo and Mack on their legacy truck. So that's a public announcement about 1.5 years ago. So Volvo and Mack truck both support GEOTAB as their legacy telematics product. And then last week, you might have caught a press release from Ford Automotive. So Ford Commercial Solutions named GEOTAB as one of 3 possible options that will be coming to market this fall, where we'll be taking data from Ford vehicles and bringing it in to the MyGeotab infrastructure as third-party data. So we're excited about that, right? So we have to foster an engaged ecosystem. Our business development teams, Sherry Koch and Scott Soteric, leading, have done a great job there. Global accounts. We have so many accounts now that have more vehicles than just in the United States or in Mexico. They're operating globally. How do we go to market globally? We had to create some consistency about our global go-to-market practices. We expanded our European team, opening up the Madrid office very recently this year in February. Then we expanded our Latin American sales. In fact, Latin America is absolutely phenomenal right now for us. And we obviously expanded our customer experience division. We didn't have that division prior to May 2016 that was integrally focused or integrated into our pre-sales and post-sales operations. So we had to create these teams in order for us to achieve our 1 million. That was all the foundation work we laid down 2 years ago to prepare us for success this year. We had to plan that far ahead. So in May 2016, we went back into history. We said, well, here's our clusters of 6 different reselling partners. How do the fleet management partners, my GEOTAB-focused resellers, smart fleet resellers, data-focused enterprise fleets, ELD guys, all compare? Well, you can see that's pretty equal, actually. It's not too bad, hey? So we actually was surprised when I took a look at this. I wasn't surprised when I took a look at this chart. The value-added resellers is the largest piece of the pie. We've been saying that, and thank gosh, our resellers have been listening to us. VAR's solutions, connecting our solutions to the customers, what a VAR does, right? Even pick one marketplace partner at the back of that room, integrate it into GEOTAB, you're a VAR. You're busy engaging in this incredible ecosystem that GEOTAB has provided. Well, 1 year later in 2017, let me see if I can get 2017 up here. Pilot is pretty much the same, right? So we grew the company. We ended May 2017, we had about 800,000, 750,000 subscribers. The largest growth segment across all of them, not surprisingly by 2017, was the truck value-added focused resellers. 263% growth from the year previous, so it's pretty impressive. But as you can see, the pie's kind of expanded themselves. The ELD opened up a little bit, but overall, all markets grew. Over that course, the smallest group grew by 40%. The smallest group grew by 40%. It's pretty impressive. So somebody said, wow, that's what we said too. And then finally, in May 2018, these numbers are as of May 31st this year, so a couple weeks ago, the VAR channels exploded in the last year. So the ELD wasn't the thing that drove our growth in the last year. It really is our VAR network. It's our partners that are embracing our ecosystem that are the fastest growing channel that we have inside GEOTAB. So I'm happy that we've got a healthy and vibrant ecosystem of partners that are equally enthusiastic, equally growing the business, and it just makes for us, as a diverse company, to be able to go and expand our operations globally across all lines of business, and it just means for a very healthy, profitable organization inside of GEOTAB. So a couple things other, because it's GEOTAB by numbers, and again, shout out to Melanie Sir of our marketing department, who is our blog master, blog editor. I don't know if you follow our blog. Please go to geotab.com/blog if you don't. It is phenomenal. And you can see from the chart, these are our blog posts. We have these campaigns as well. So the number one thing in marketing is SEO, search engine optimization. You want to be ranked Google. That's the name of the game. So when someone types in something, you want to be searchable in the top 10. That's the number one objective of our marketing spend, is to become and maintain a top ranking on Google. Well, how do you do that? You've got to be a thought leader. Google understands it. You can't do that. Just the pay-per-click stuff is a waste. Sorry, Google. Not a waste of time. We do pay-per-click. It's not the sole way we want to be number one on Google. We want to be number one or in the top 10 by thought leadership, putting relevant, updated, current content on the web that people read, engage, and reference and redistribute. That's how we do it. Well, Melanie is, as I said, the master of that. All these little circles that you see across the line are campaigns that we did. And I hope, again, if you follow us on the blog, it's really incredible. We do these campaigns. When Hurricane Harvey hit Houston and flooded Houston out, we did an accelerometer campaign and where we took a look at, and a GPS campaign, all the vehicles leaving Houston Basin. And we combined that with some of our fleet stories on how do they prepare for Hurricane Harvey. One of the learnings from Hurricane Harvey from our largest fleet customers, our second largest fleet customer, was they learned to use our fuel tank level sensor. And they said that for across the country, actually, as of Hurricane Harvey, 1 week prior to, every vehicle had to start finding fuel at 50% fuel tank level. Company policy, done. So if you came down to, because finding fuel is the hardest thing in a hurricane, right? Finding fuel, you don't want to be without gas. So they said, we can get the fuel tank level from all of our vehicles, and they just set it out every single day. They sent out the note to all of their drivers, if your vehicle is below 50%, find fuel now. Go find fuel. And they learned that, and they distribute that across even for the northern states, which is interesting. But this blog posts are just phenomenal. The privacy mode one is one we just recently, Neil talked about it yesterday, just recently posted. Every employee inside GEOTAB has to write a blog post. So this was written by Valeria in our NPI group on privacy mode, it describes the feature that Neil talked about yesterday. So you want to stay current about GeoTab? Subscribe to blogs. You'll find it there. And if you're a partner of ours, even if you're a customer of ours, redistribute the blogs that are cool inside your company. We want you to redistribute the content. It's not biased content. It's thoughtful, company, telematics-wide content that we're writing there. We want you to join our community. 30,000 blog subscribers right now. We're the bloggiest company in telematics, and I'm proud of that number. So do visit our geotab.com/blog, subscribe to the blog, and when you do subscribe to the blog or when you do hashtag out, just remember GeoTab Connect. If you're taking pictures here, we'd appreciate it. That'll probably get our rankings up a little percentage as well. In addition, on the marketing department, we look at major campaigns, big data campaigns, the most dangerous highways in America. We did a really cool one, I thought, on fuel consumption by truck by state. So you could see that in Colorado, you're getting 6.9 miles per gallon. In Florida, you get 7.2 miles per gallon. It's all through big data. So we can grab all this aggregate data, we can cut it up into various states, we can do it by make and model of vehicle, and we can plot this stuff out. And if it's interesting, we can write white papers on it, and we can produce that stuff. We produce that into the marketplace, and we track. These are that's the results of the daily sessions in the Quietest Roads campaign. It was a beautiful one, by the way, Quietest Roads. So these are road traffic that is underpopulated, I guess low volume of vehicles, but spectacular photography. So you can see these amazing pictures, and there's no one driving on those darn roads. So we said, like, if you want to go on vacation, check out the pictures, take a road, you're not going to get into a traffic jam, and you're going to see some amazing mountains and forests, go for it. That's the mechanics of the campaign. It translates to this in terms of brand. Brand is key to GeoTab. Our brand is everything. We're a thought leader. We want to be perceived and thought of as a thought leader, a guidance counselor of the industry, and it's paying off. The little blue circles are those campaigns, and you can see incrementally over time, way back to 2013, how we track our Google rankings for the word GeoTab. How is that working out for us? Now, I'm not going to say the names of the brands here, but you can see them for yourselves. We also track the competitors' brands. So how are we doing versus our competition? And we track that stuff, right? So it's important that we're able to do that for our own brand. How are we doing? Are the campaigns that we're putting out there meaningful? Is it impacting our marketing goal, which is top 10 or #1 Google ranking? So you have an objective, you play out your strategy, you measure your results, and then you benchmark your results against your competitors, and then you know if you're successful or not. And that's really what data analytics is all about. That's what GeoTab is all about, benchmarking and collection of data. And really, for the next hour and a half, for our next few speakers, we're going to talk about that. What is data analytics? How have GeoTab APIs impacted your business strategy? What does artificial intelligence mean? What's the impact of AI on fleets? AI, it sounds like a robotics thing, and probably something in a factory with little robots that pick up square boxes and drop them and put them someplace else. I mean, when I was in university in 1984, I think that's the extent of what I thought it was. I think our speakers today have taken it to a next level. How important is the GeoTab marketplace ecosystem to connect multiple streams of data of consumption? Because used to be a linear one-to-one. It was the GeoTab technology and then the buyer of the technology. It was a one-to-one relationship. That's how telematics has been sold. Still, the vast majority of telematics is sold in a one-to-one relationship. My tech, you're the buyer, you have my UI, you consume the solution. It's not the future. It's one to many. It's one device, multiple streams, multiple people or stakeholders in that data. It could be the risk management department, the fleet department, your outside routing and scheduling partner, any of the people at the back of the room. That's what the future is for our data. And we've got to cater for that, right? We've got to be able to identify that. And then what does the impact of benchmarking have in terms of the adoption of telematics? I think it's going to absolutely take this thing to the next level of hockey stick. When we were able to say, hey, your idling is 8%, and the customer says, is that a good number? Is 8% good? Well, 8% is good relative to the other vehicles, and here's the culprits in your fleet that are above 8%, you should manage them, but that's not what the customer's asking. Is 8% good in the industry? Of my fleet, my vocation, in my city, is 8% a good number? Well, as a matter of fact, everybody else that's got Ford F-150 pickup trucks in Columbus, Ohio has got 5%. Oh, well, so 5% is my target then. So you have to target against something, and that gives somebody an ROI and a dollar target to try to achieve. So before I bring out the next customers, we asked this question yesterday. I did a little interview man on the street, and I thought I'd share with you some of the observations of the crowd, so enjoy. Hi, I'm Colin Sutherland, Executive Vice President for GEOTAB here at the corner of Query Street and Big Data Boulevard at GEOTAB Connect. I'm here with Aaron Kim from Smart Witness. I'm here with Benedict Cumberbatch. He's a recent GEOTAB employee. Shane from Paper Dodo. Adam Shapiro with E Squared Communications. Melanie Sayre. Anthony from Matrix. Here with Alan Cawse. Here with Matt Chapman. Mauricio Munoz. In one word, describe GEOTAB.
Wow, that's tough. Revolutionary.
Power.
GPS tracking for the world.
Technological. One word, that's a trick question. It's so much. Reliability.
Forward thinking, can I use two?
It's a hyphenated word that counts.
Innovation.
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 Innovation. I think, what we bring to telematics and what our staff do internally is just innovate in an already innovative space. So we're really at the top of the game here.
What does the acronym API stand for?
Put me on the spot.
Application programming interface.
Application programming interface.
Being able to connect into the code of GEOTAB.
So what does API stand for?
I don't know.
Shane, I just had to look it up on the internet myself.
Accessible program interface.
Application something interface.
Applied programming interface.
Application programming interface.
God.
Can you use the word API in a sentence?
Yeah, can I have the API so I can integrate your data into my data?
What does the acronym SDK stand for?
Software development kit.
Software developer kit.
Software developer kit.
SDK. It's a car company out of Sweden.
Software development kit.
Solution development kit.
Okay,
Software development kit.
Okay, well, I'll give you that one. French Canadian. Give me one French Canadian word that GEOTAB means.
Gigantesque.
One last question for you. How are you using data to run your own business?
Compare all our different clients and analyze their data and give them, comparison to better drive their fleet forward.
We do a lot with mapping data, so anything that's location-based, we are interested in and utilize and then republish back out to your GEOTAB partners.
We just love getting the data to tell stories. So for us, it's about what are people doing with the data, how are they benefiting, and how are they using it to make their business grow.
How are you finding it so far?
It's great. I think the space is really cool. The presentations have been really informative so far, and just everybody's has been really knowledgeable and interested in what we do.
This is Colin Sutherland for GEOTAB Connect 2018, signing out. See you next year.
Please welcome to the stage Neil Cawse.
Good morning, everybody. Good morning. Trust you're having a good conference, and it was a good event last night, and everybody got a good opportunity to network and have some fun. Today, in my presentation, I'm really going to only talk for a couple of minutes, and then we're going to hand over to Mike. This story about AI hyperreality. Why are we talking about this? First of all, I don't want anybody in the room to be intimidated. We are an IT company. We have to understand AI. We have to know how all the machine learning works. We have to program the stuff. But that's what we're here for you. We're here to make sure that we take the pain out of the AI, we build it into the product, and you then have the best tools to be able to go and sell. So the point of this presentation is really to empower you with enough information about what AI is and what AI isn't, so that over the next couple of years, as those products and features roll into the GEOTAB product line, that you can talk to it, you can sell it, you know what it can do and what it can't do. I think we all know that AI is coming, and so one of the things that is really key is not to be left behind. If we are busy focusing on AI, you need to be a leader in your own organizations and make sure that you understand AI and you take AI to your customers. Now, let's just think about AI for a second. Let's wind back time 10 years ago and listen to what the analysts were telling us. 10 years ago, if you remember, everybody was telling us the cloud, big data, and IoT were going to be the next big things. Remember, everybody was saying, and back in those days, It was a little bit unbelievable. Who would move their data to the cloud? How can you trust your data sitting in the cloud? I want my data locally. People didn't understand what big data meant. Well, we've got databases already. What on earth is big data? And then IoT, this idea of IoT sounded a little bit abstract. What does it all mean? And so I went and I looked, who were the largest companies in the world 10 years ago? And it was interesting. I took the top 10 companies, and the only IT company in the top 10 list was Microsoft, and they were at 6. The world back then was dominated by petrochemical companies, by industrial companies like GE. Now, let's fast forward to today. Believe it or not, the top 5 largest companies in the world are all IT companies that have placed their bet on those things: cloud, big data, and IoT. So do you think we can sit in this room today and ignore AI? I don't think so. We know that when we look 10 years ahead, we know what's going to dominate. And so I think we need to have a bit of an appreciation and understanding. Now, as always, we know that people underestimate the short-term impact of technology. I mean, overestimate. But they underestimate the long-term impact. So, I think we saw in the presentations yesterday, it's happened time and time again with TV, with globalization, with the web, and even the car when you wind it back. And so the reality is, for all of us, timing is everything. Picking the right time in which we jump in when we make it a big deal. So we know AI is going to change the world, but what are the negatives? Well, this is a bit provocative, but they designed AI wrong. Now, I know a little bit about AI. I was going to go and do a master's in MIT doing artificial intelligence when I first came to Canada, and took the fork in the road and started GEOTAB instead. So the problem with AI today, people are talking about an AI winter. I think that's over-exaggerated. But the best way to describe the problem that we face with AI today, little problem, is that, let's take an example of Google. Google have one of the best image classifiers in the world. An image classifier is something, if you use Google Photos, which is an absolutely incredible product. You put your photos in, and Google, you can search and you can say, show me all the times that I was in California and I was on the beach. And it'll show you all the pictures with you on the beach in California using AI. But they use an image classifier to figure out what does a scene look like. So they can look at the scene and they can see it's a beach scene. They can see there's a ball on the beach, and they can see that there's a dog running. And they'll say all of those things in the scene. And so what some of the researchers did is they took those images and they said, well, can we hack this? Let's see if we can hack AI, and what does it mean? And so they introduced a little bit of noise. Like snow on your TV in the old days? I think you have to be above a certain age to remember that. They introduced a little bit of noise into the image. And so you can put the 2 images side by side. And to you and I, it looks perfect, right? They're the exact same scene. It hasn't changed. But now the image classifier comes back and tells us that it's a zebra. And you go, this just doesn't make sense. And so that's part of the problem with AI today, is we don't understand how AI works. What we do, we create a big neural net, and we train it. We give it a bunch of information on the one side, and we tell it the right answers from the wrong answers. And then it's this black box. And we hope that every other image that we give it in future, it will be smart enough to figure out the right answer. And if it doesn't, we just don't know what went wrong. And so what is happening with AI is a rethink on how we approach AI. And it's going back to the way babies learn. Right? If you think about a baby coming into this world, and they look around the world, the first thing that happens is their eyes can do edge detection. It's actually built in and programmed into your eyes from birth. And they know the edges of every single object. So we need to teach our machines to figure out edges of objects. Then it does lighting compensation. So if you take a cube and you shine a bright light on one side, our brain doesn't even think that the other side's black. It's not black. We know it's the shadow, and we compensate for that, and we know it's all actually the same color. And then we do perspective compensation because it's far away and close. And we do semantic reasoning about what the objects are. And then we do object classification. And all these pieces will need to be built up in layers using AI. So there's a big change happening in the AI world. So the problem is that self-driving, we have been able to get 99% of the way there relatively easily. And it's amazing. Get into an autonomous vehicle, and you click a button, and the Tesla vehicle is taking you, and it turns, and it stops when it needs to stop. It's very impressive. But the problem is, I believe, and we're going to learn a lot more from Geoffrey, who's far more capable of commenting on this than me, but the last 1% is going to be 100 times harder, because we now have people's lives at stake. Now, I'm hoping to be proved wrong. I mean, there's some amazing stuff coming out. Waymo are the people to watch. What Waymo is doing is incredible compared to the other competitors, all of them. They have 2 million miles of driving out there in the autonomous driving space already, and they're putting their money where their mouth is. You heard yesterday they're ordering a huge number of vehicles to actually go driving. So, you know, we'll see how that turns out, but hopefully I'm wrong. Now, one of the things, again, to understand, we talked about this yesterday, is AI is powered by data. So you have to have your big data program in place before you can start thinking about AI. And remember what we said, is that the company that controls access to the data is the company that will be in control. When a company like Google says that all the AI technology we're making available for free, everybody can use the AI technology. Why? Because our competitive advantage is our access to the data. We are the ones that cannot be disintermediated. And so we need to remember that. We know that there's issues like legislation needs to bring back control to consumers. We know that data collection will drive AI. That is a really important part and the future of AI. Now, the future leading companies are being forged now. And then we know they're only going to emerge in the next 5 to 10 years. So at least if you think about who owns the data, you will be in a strong place. But finally, I want to end off just telling you that Mike is going to come up here, and he's going to talk to you a little bit about how we are using AI. He is going to educate you on, well, how does AI apply to the work that GeoTab does and the work that you folks do? How are we going to be using it and implementing it into the product in the next while? And I think that's the most important piece. In the meantime, become data savvy. We spoke yesterday about the importance of big data. Use big data in your own organization. Be familiar with the database. Start understanding how impactful big data is in your own organization. So with that, I'd like to welcome up Mike onto stage, and he's going to tell you all about how GeoTab uses AI.
Much. Cheers. Thank you very much, Neil. So I'm here today to talk to you a little bit about AI, hype versus reality, what we're doing from an AI perspective here at GeoTab. We live in this messy world, full of data streaming in at us every second of the day, and it's quite complex to make sense of that data, to derive insight, to derive value. It's tough for us at GeoTab to do. It's not an easy thing to find the right tools to provide our partners, to provide our customers. There's just a mammoth amount of data. And to give you some insight into some of the data that we're dealing with, I'm going to throw a few numbers at you. 21, the number of trips that we make to the sun in a month. 11, the number of trips that we made to the sun just last June in a month. That's a staggering increase in just 1 year. 3.2 billion. The number of kilometers collectively driven by all of our fleet, again, within one single month. 1.2 million. The number of active GeoTab subscribers, thanks to all of our partners here today. Up from 1 million just on February 14th. 2.5 billion, the number of raw records captured by all of our devices on a daily basis. And if you were to interpolate that data to every 10 meters by 10 meters, you'd be looking at 20 to 30 billion records on a daily basis. 5, the average age of fleet vehicles in our entire fleet. 60 million, the number of erratic driving events that transpire in a single month across all of our vehicles. That's harsh braking, hard cornering, hard acceleration. It's a lot of data. And machines are collecting this data faster than ever before. If you think back to the 90s, when you think about how data was collected, data was really collected as a result of human input. So I think about, the old days of Alta Vista and Lycos and Excite. As I'm entering my search queries into the search engine, it's collecting my data, right? Long before the times of Google. Then you think about the days, the decades gone by. Now we've got these Fitbits that are on our wrists, right? So as we're walking and we're cruising around, we've got our pulse being detected. We've got our gait being detected. You can detect our height. So some really cool stuff. And so that's as a result of what we're doing. Machines collecting data as a result of something that humans are doing. And then there's this kind of third wave of data being collected as a result of machine movement. So you think about a windmill, and windmill as it turns itself in the right direction just to capture the wind enough to generate just enough energy. So that's data collected as a result of machine movement. So machines are collecting data faster than ever before, ever in history. We can't stop, we can't forget how powerful the human mind is as well too, how good we are at perceiving the world around us. You know, I live out in the area of Burlington, and you know, as I walk down my street, we've had a terrible time with wind this year. And you look down the street and all the trees that have fallen over. As I walk down the street, I can probably pick out which trees are about to fall. You know, I have this great perception of the world around me. It's, you know, born in us at an early age. I look at my 2.5-year-old son, and I know he learns cause and effect. You know, I put the glass of water on the table. I watch him push it, push it, push. He knows what's going to happen when he pushes it to the edge. It may not stop him from pushing that cup over, but he, you know, he learns cause and effect at an early age. And we're good at perceiving the world around us. What we're not good at doing, though, is making sense of large volumes of data. That is something that AI really and truly excels at. And that's something that I'm going to talk to you how we're leveraging that data today. Step back a little bit. How many people in this room have used a typewriter before? Okay, I see a few. Commodore 64? Atari? More than I thought. That's awesome. Why aren't we using it today? I mean, the answer is quite simple. There's simply a better thing out there. There's a better tool to do that job. And that's where AI comes in. It is a much better tool to deal with these mass volumes of data. AI is not a fad and maybe not be adopted as quickly as we think, but it is not a fad, and it can help us do some excellent things. So I was at a conference, must have been a month or two ago, and this guru in AI in the data science realm in Toronto was talking. And he helps financial companies with AI problems. And he told an interesting story. It was his great-grandmother immigrated to Toronto decades and decades ago, set herself up in the fashion district. And she was a seamstress. And all of a sudden, now she's using these newfangled machines, sewing machines, that help her do something incredible. Revolutionized the world for them. Fast forward a few decades, and he's in that exact same building in the fashion district, starting his AI company, helping people in the financial district with these newfangled tools in AI, right? So you can see how AI is having an effect on our world. There is such a growth in the number of connected vehicles and connected devices that we have today. 23 billion connected devices today. For every one person, that is 3 connected devices. And by 2025, we're projected to be at 75 billion connected devices. For every one person, that's 9 connected devices. All these devices talking to each other, AI communicating with each other. It's incredible. But so what? Who cares? Like, how does that have an effect on me? Why is it important? It's important because it will disrupt business. And I'll tell you how it will disrupt business by one very, very simple example. Your refrigerator ordering food for you, right? So my refrigerator ordering food, so it looks in my fridge and says, oh, Mike, you know, you're out of milk, you're out of bread, I'm just going to order something for you. Okay, so it orders something from me. So what transpires after that? Is a drone come and deliver me the food that I need? Is there an autonomous vehicle that is circulating around my neighborhood filled with the common necessities that can just get me what I need? You know, how does my fridge decide who it should buy from? Does it choose the cheapest option? Does it choose the option that will get me my food quickest? Does it decide all of a sudden that it can, influence my diet? Right? Is it going to make me a healthier me? Does it know that, hey, Mike's been exercising a lot, it's communicating with my Fitbit, and it knows I've been eating healthy well, but it also knows I like cookies, so is it going to order me a cookie? Right? So there's all these little things that can transpire. And how does that even affect the world of takeout and delivery? Now that your fridge is already stocked, are there going to be fewer deliveries to the home? So you can see how just one little thing can impact our entire economy, not only from a transportation perspective, from social norms and beyond. And this isn't a joke. By 2021, there will be 3 billion machine-to-machine communications happening across the globe. So this is not a joke. This is happening, and it's a result of what's happening in the AI ecosystem right now. So AI, like I said, can make sense of these mass volumes of data much better than we can as humans. And some of the things I think that can really benefit from this, you think of incidents like what happened in Barcelona, what happened in London, what happened in Toronto with these vehicles just rampaging into crowds of people, like these disastrous situations. And you think, it happens from a terrorist perspective, it happens from mental issues. But can these things be prevented? Can AI have looked at the driving pattern of the vehicle? Can it have integrated with a social media profile to look like something's not quite right with this guy? Can it look at the pulse rate from his Fitbit to see, hey, there's an elevated pulse happening right now? Can all this data together be used to help thwart these possible situations? Obviously, there are tons of ethical and privacy issues to deal with there. But these are the things that AI can start helping us make sense of, this massive amount of data that is out there. So I thought I'd talk to you a little bit about where we stand here at GEOTAB from an AI perspective. So it's not all about C3PO, it's not all about R2D2 and data. It's about chatbots, it's about Siri, it's about Google Home, predictive models. There's so many subsets of AI. And I'm not going to get deep into anything because we've got the godfather of deep learning coming to talk after me, Geoffrey Hinton, and he'll do a great job on that. But what I thought I'd talk to you about is where we're standing. So we delve in the area of AI called machine learning. And machine learning, we deal with both supervised and unsupervised models. And in a supervised model, what I'm really doing is if I want to be able to figure out, what a tree is over there, I'm going to give it many different examples of what a tree is, and I'm going to give it different labels. So I'm going to say, here's a tree, this is a tree, this is not a tree. And over time, it will learn what a tree actually is. In the unsupervised way, what we're doing is we're giving it many different examples, but we don't have the label. We can't tell what is a tree. So what it does is the machine learning tries to figure out and cluster it in such a way where it can figure out what that tree is. But it's oftentimes not intuitive to us what has happened there. And one of the things I think I'd like to let you know is a little bit about how machine learning differs from traditional programming, because that's important to understand as well too. And so how machine learning differs from traditional programming is, in traditional programming, as I write my code, I've got a lot of if-then-else clauses, I've got a lot of data, and so if I'm looking at making a program that will tell me if this is a tree or not, I'm typing in my code, I've got my data coming in, and the output is it's a tree. Whereas within machine learning, it's a little bit different. You've got your data coming in, you've got a lot of output, a lot of examples, and it's generating that code for you. So it's fantastic if you look at doing this at scale, but it's also complex because how do you then go and debug this and figure out what's going on within this machine, within the machine learning algorithm that you developed? It's quite complex. Some interesting things are happening today, though, when it comes to AI. At the Google I/O conference last month, some amazing things were revealed. And if you haven't had a chance to look at it, I'm going to show a video in a couple seconds here. And what they've done is they've developed a means of establishing better communication between humans and machines. It's called Google Duplex, and I'm going to just queue up the presentation for you so you can see that right now.
It turns out a big part of getting things done is making a phone call. You may want to get an oil change schedule, maybe call a plumber in the middle of the week, or even schedule a haircut appointment. We are working hard to help users through those moments. We want to connect users to businesses in a good way. Businesses actually rely a lot on this, but even in the US, 60% of small businesses don't have an online booking system set up. We think AI can help with this problem. So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a woman's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. By the way, when we are done, the assistant can give you a confirmation notification saying your appointment has been taken care of. Let me give you another example. Let's say you want to call a restaurant, but maybe it's a small restaurant which is not easily available to book online. The call actually goes a bit differently than expected. So take a listen.
See how may I hear you?
Hi, I'd like to reserve a table for Wednesday the 7th.
For 7 people?
It's for 4 people.
4 people? When? Today?
Next
Tonight?
Wednesday at 6 p.m.
Oh, actually we reserve for like upper like 5 people. For 4 people you can come.
How long is the wait usually to be seated?
For when, tomorrow or weekday or?
For next Wednesday, the 7th.
Oh no, it's not too busy. You can come for 4 people, okay?
Oh, I gotcha. Thanks.
Bye bye.
So some pretty cool stuff there. It's phenomenal. So as I got to thinking about that, I'm like, wow, this is pretty awesome. Like, how would duplex be used for GeoTab? Is there potential there? Now obviously we're probably a little ways away from that, but we have to get our data in a way that when we're ready for duplex, it can be used. It can be used to help accelerate the way we do things in our businesses. So I have 2 different potential examples for you here. And one is kind of like a government smart city perspective. So it's, I've set the stage with a disgruntled citizen who is very upset because she's got speeding happening within her neighborhood and she's calling the government. So let's have a listen to what that would sound like.
Hi there. I'm calling to advise you that the speed bumps around the school in my neighborhood just aren't working.
I'm sorry to hear that. Can you tell me what school you're talking about?
Yes, around Sunningdale Public School.
Hold on a sec. Just looking that up. Ma'am, I've reviewed that area, and the average speed during school hours is 40 kilometers an hour, going east along Oxford and 42 kilometers an hour going west.
Well, that's not what I'm seeing.
Ma'am, if you'd like, I can share the full report on this area that was conducted over the last month. Can I send this to your email?
Sure, it's jane@doe.com.
Thank you, ma'am. You'll have that shortly in your inbox.
So this may seem a little far-fetched, but the data that we have already within GeoTab can do this. And our data provides that insight today. If you were to jump into the session yesterday with Frank Gaynor and with Brenda, who were talking about what we did with the town of Oakville, we have thousands of vehicles driving around Oakville already. We did this same analysis for them. You plug that on top of Google Duplex, and all of a sudden you're enabling operations within a smart city. And this is the thing that you can build upon. So it's GEOTAB's AI built on top of that. We've got Duplex. Here's another example that I'm going to share with you as well too, and it's an example around predictive analysis. It's a car that understands that it's got a maintenance issue and it needs to be serviced. So here's what that might sound like.
Hi, I'm calling to book a service appointment for Mike.
Okay, let me transfer you to the right department. Hold on.
Okay, thanks.
This is Andrew in service. How can I help you?
Yes, I'd like to book an appointment for Mike on his Ford F-150. The battery isn't looking in good shape, and he'd like it replaced.
Okay, how about next Tuesday morning at 9 a.m.?
Unfortunately, that's not going to work. Do you have any morning slots the week of the 15th?
Yes, how about Wednesday the 17th at 9:30 a.m.?
Sounds great.
You're all booked in, sir. We'll see you then.
Thank you.
So I was hoping we could get Kit from Knight Rider as the voice of the car. That didn't work out. But again, we're not far off from this kind of thing. Have a look at the Pepsi Frito presentation later on today at 11 o'clock, and you'll see what we're doing there from a bad battery detection perspective. Really interesting stuff, looking at the cranking voltage, looking at the temperature and how that impacts batteries, and we are showing which batteries are at most risk and that will need replaced. Again, you build Duplex on top of something like that, but that's not the only data that you're going to need. You're going to need routing data because we need to know when to schedule that appointment. You may need to look at data.geotab.com and look at the service centers in the area that have the quickest turnaround time. So you compile all of this data together in one cohesive system, you apply a Duplex on top of that, the operations just get streamlined so much better. So, I mean, all of this data that is out there, there's a common misconception that machine learning is this mammoth thing, okay? In fact, the amount of machine learning code required to do anything is actually quite small. It's all about the data preparation. Neil talked a lot about this as well too. There's so much investment in time to cleanse your data, to filter your data, to get it ingested in the right formats, and that can't be overlooked. Machine learning code is just a small fraction of that. And the great thing is that we start with quality data too. We start with quality code. GeoTab's curve logic is incredible. The problem with machine learning, you put garbage in, you're going to get garbage out, just like anything else. So we have excellent quality data to work with. I'm going to share with you just what our stream process just kind of looked like very quickly, so you get an idea of how we deal with the data. So as the data comes in, we've got individual vehicle data coming in, about 100 to 200,000 records per second that are coming into our big data ecosystem. And we have about a 5 to 10 second lag from the time that the data reaches our gateway servers to the time we're able to do analysis on this data leveraging Google BigQuery. And we want to make sure that it continues to have that amazing lag, 5 to 10 seconds. Well, why is that important? Well, as we stream 1 million, 2 million, 3 million vehicles into our entire ecosystem, we need to make sure we can activate on this collective data very quickly. I need to be able to determine if there is a ton of people slamming on their brakes, causing ABS activation to go off. There's a black ice issue potentially. We need to look at hyperlocal precipitation. We're already doing that. Looking at when the windshield wipers are going off, we can tell you within 150 meters by 150 meters where there is hyperlocal precipitation. Really interesting, but we can only do that if we're looking at all of our data at scale very quickly. And we're implementing a lot from a streaming analytics perspective to be able to do these kinds of things. Once we've got all that individual vehicle data, we interpolate this all. Because curve logic is great. It's fantastic. You get the right values you need. But in order to do a lot of analysis, sometimes you need to interpolate. So we take that 2.5 billion records coming in and stretch it out so we get 20 to 30 billion records. That's important for analysis. If you want to look at, say, cellular coverage, you've got a point here, you've got a point here, but you need to know the cellular coverage at the points in between. So we interpolate all of that data. And we take all of our exception data, all of our status data, and we join that with all of our longitude and latitude data. So we have, for every single point that we have collected in our system, whether you're harsh braking, whether you're speeding, there is a location associated with that. And that's all available in our interpolated data sets. Once we do that, we filter all of this data out. So as you can imagine, there's going to be some outliers. We had, as we were looking at ambient air temperature, because we get ambient air temperature on about 30% of our vehicles right now, so we can look at hyperlocal air temperature across the globe. And as we were looking at it, we saw some crazy outliers, like 60 degrees Celsius, 70 degrees. It just didn't make sense. So we have to filter out the outliers that do occur from time to time. But interestingly enough, we did find a few areas where we thought there were outliers and they just weren't. And if you were at my talk about a couple of years ago, I focused a lot on small data. And here's why it's important never to forget about small data. Because as we looked at the area of New York in January, we were seeing 20 degrees Celsius. And we're like, well, we got to get rid of that. No, hold on a second. Let's have a closer look. What's in this area? It happened to be a parking garage. And a covered parking garage. So do we just get rid of that data? No, now all of a sudden we've got a data set that tells us where all the covered parking garages are, right? So it's about how you look at the data and how you interpret the data. So you may need to filter out some things, but be very careful about what you filter out. Then we transform all of this data and we aggregate it. So we look at, for every individual vehicle per day, how many harsh braking events did it have? How many speeding events did it have? All this kind. That's important because we need to be able to create queries and do things in a much quicker fashion. And to do that on an aggregate data set is much quicker than on our 2.5 billion records coming in on a daily basis. And then we aggregate it across our entire ecosystem too. So we look at hazardous driving areas and we create all of these amazing aggregate data sets, not for a single vehicle, but across the entire set. And then we create this feature mart. And this feature mart is what's used for machine learning, right? It's this whole process coming from the individual vehicle data all the way through this feature mart. Once we get here, now we can start activating and doing some really cool things with the data. And so as you can see, there's this extensive data preparation framework, and this lays the foundation for machine learning. It is absolutely crucial and essential. If you don't do it, you're not going to be able to activate on machine learning. I'm going to tell you about what we're doing from a machine learning perspective right now. And for those of you who visited the benchmarking session yesterday, you will have learned a little bit of this, but it is phenomenal. So what we're doing is we're classifying the vocation of a vehicle. What is the vehicle's purpose in life? What is it meant to do? As you can imagine, with over 1 million vehicles, over 26,000 customers, we've got customers who have garbage trucks, who have utility vehicles, who have rental cars. The list goes on. And how do you make sense of all of this data? It's complex. And the reason that we thought along the lines of vocation was we thought, okay, well, when we're benchmarking, maybe we benchmark based on industries. That's the right way to do it. And it isn't. It's not the right way to do it. And in a single industry, you can have so many different types of vehicle movements. And if you're going to benchmark, you can't classify them all together. Not to mention the fact that if I'm going to rely on customers to specify which industry they're in, there's an industry in specifying industries. If any of you know anything about NAICS codes or SIC codes, how do you know which industry you belong to? It's quite complex. So we decided to look at it from a vocation perspective, how the vehicle is actually moving. What is its primary purpose in life? And we're amazing at collecting really strong pieces of data across the globe. But what we're not good at right now is labeling that data. So what helps us label that data is that feature mart that we create. So we created a feature mart that allows us to look at, okay, this kind of looks like a school bus vehicle. This kind of looks like an office vehicle. This kind of looks like a utility vehicle. And that's how we're doing it. Really, really interesting. We started off simple, right? We labeled manually about 7,000 vehicles manually. And we realized that that wasn't a scalable approach. But we found a scalable approach. And when we found that scalable approach, now we're able to classify about 15 different classes of vehicles, vocations of vehicles. And we will get better. We'll have more vocations, but we're starting off with these 15, and those will be available to you very, very shortly within my GeoTab. So really excited about that. And to give you an idea of what these kind of features or the vehicles look like, I thought I'd play a bit of a guessing game with you guys. Okay, so what I'm going to do is I'm going to show you some data that represents a vehicle class. I'm going to see what everybody thinks. It's called What Am I? So what do you guys think this is? Is it A, a school bus, B, an office worker, or C, a courier? All those who think it's A, raise their hands. A is a school bus, sorry. I've got the notes here. B, an office worker. C, a courier. Most people have no clue, I know. It's a little confusing. The actual answer is A, a school bus. And the rationale for that really is, if you look at the axes on this, what you've got on the x-axis is the time of day, and on the y-axis is the day of week. And school buses generally operate, if we look at, this is 3 months of data. If you look at about 3 hours-ish in the morning and 3 hours-ish in the afternoon, it becomes more likely to be a school bus. Let's have a look at another one. So what am I looking at here? Is it A, a courier, B, a long-haul vehicle, or C, a utility vehicle? Those people who think it's A, a courier, B, a long-haul vehicle, okay, C, a utility. Okay, not everybody's participating in this game. The axis change, yeah. This is a different feature. But so what we're actually looking at is A, a courier. I can see where long haul might have come to play. So this is a measure of the frequency of visits to the top 50 square kilometer locations over the last 3 months. So this means that I've done a ton of small trips in little areas. And that makes sense for a courier vehicle because as a courier, I may go to a square kilometer area and do a bunch of little trips there, then move to the next area, and that creates that diagonal line. Here's the last one I'll show you guys. So what do you think I am? Am I A, a police cruiser, B, a delivery truck, or C, a rental car? Those people think it's A, a police cruiser, B, a delivery truck, C, a rental car. Lo and behold, the answer is A, as they all were, a police cruiser. And let me explain to you what's going on there. So this is a measure of the direct distance to point, and the actual distance driven over a period of time. So if I was Mike driving to the grocery store, if I'm going to go there pretty direct. So my actual distance is going to equate my direct distance, and I would get a diagonal line. But if I'm a police cruiser, I may start off at that origin, drive around, and meander, and my actual distance is actually quite longer than that direct distance, which equates to a visualization that kind of looks like that. So why does this matter? Why does vocations even matter to me? So I've talked about matters from a benchmarking perspective, but it also matters from the perspective of actually understanding how your fleet is changing over time. And that's important. And that might not be important for, 10, 20, 30 vehicles, but as you start getting up there, hundreds, thousands of vehicles, understanding how your fleet is changing over time can give you some true insight. Let's give you a couple of different examples. Say I'm in the oil and gas industry. I've got my Ford F-150. I'm going out to the rig day in, day out. That's been my job for the last year. But all of a sudden, I've changed to an office worker, right? I'm going to and from the office, only a single kilometer. Do I really need that same Ford F-150 to do that? Can I optimize my vehicles a little bit better? So looking at these vehicle vocations, classifications, even looking at how they change month over month is incredibly valuable. Let's take a look at another example, which the guys talked about a little bit in the benchmarking session yesterday, a pizza delivery model, right? So I've got my regular pizza delivery model. I'm a hub and spoke guy, goes out and delivers pizza. But I've got a new model that I want to do. I want to sell frozen pizzas. And that model is a bit different because I've got my pre-registered grocery stores that I'm delivering these pizzas to, and it's a typical kind of routed plan. So if all of a sudden I'm seeing my vocations of my fleet mix change, I can see what areas of my business are actually doing better, where I need to invest my time in. And this gives you a great macro scale ability to look at your businesses. Not to mention benchmarking. It's a massive impact on benchmarking. So for us, machine learning forms the crux of what we're doing from a vehicle vocation perspective. And that forms the crux of what we're doing from a benchmarking perspective. And I was really pleased to see how much of an impact it had on benchmarking. So as we're tackling benchmarking, we're tackling one benchmark at a time, and we're doing a scientific study on every single benchmark to make sure that we can tell you what matters for that benchmark. We don't leave it up to you, the choice, right? We will tell you based on our data. And what we discovered from an idling perspective, we looked at idling benchmark first, that vocation was the single biggest predictor of how a vehicle will operate when it's idling. And that makes a lot of sense, right? You look at a utility vehicle, it's vocation. Vocation was the single biggest factor, followed by time of day, followed by temperature. So we've done that heavy lifting. We will continue to do that heavy lifting for every single benchmark that we provide you out there. And again, this stuff will be available in my GeoTab very, very shortly. This analysis has been done, and it's really, really cool to see the fact that vocation had such an impact on idling. But to do anything here, we need to give you guys, the customers and the partners, the right tools. We need to equip you well. Let's take the example of Bob here, this stick figure. Bob, I tell him, you know what, Bob, you've got an opportunity to be in the Formula One races and to win a boatload of money. Bob's super excited, right? But Bob, all you get is this lousy golf cart, which hopefully will show up in about 2 seconds. There you go. He's not so happy. But I also tell him, but Bob, you've got all the training that you need. You've been a soccer dad for years. That should be suffice training to race in the Formula One. You're good. You think Bob's going to be happy? Bob ain't going to be happy. But if I tell Bob that he's got this beautiful Ferrari to race in, right? And we've given him training from, I don't know, James Hinchcliffe, some Formula One driver, Bob is going to be pretty pleased with himself. So that's what we're trying to do here at GeoTab. We're going to equip you with the right tools to be able to activate on data and machine learning and AI. Neil spoke about it a bit yesterday, but I'm very pleased to announce, data.geotab.com to all of our community. We did release it in beta for our partners and our customers in December. We've had a lot of traction on it, a lot of people learning what they can and can't do with data.geotab.com. It is launched over 10 different data sets right now, and we're expanding on the number of data sets that we will be pushing out. They're categorized under urban infrastructure, categorized under location analytics, and categorized under weather. We've got everything in there from road impediment data, so 600 million records on road impediment data across the globe. We've got hazardous driving locations in different areas. We've got hyperlocal temperature data. We're coming up with some really cool data sets that will be on the precipitation side. Truck detention times we will be putting in there as well too. Intersection insight. And here's where we need input from the ecosystem as well too. We will never disclose any private information. This is all aggregate data. We will never disclose private information. But if there is aggregate data that can help you, our partners, our customers, we need to hear from you. Because you guys are out there on the ground and understand what your customers need. So please do reach out to us. We're at any of the booths, and reach out to me at any point in time. We're seeing some interesting adoption from folks like on the smart city side. So Smart Columbus operating system is now ingesting all of our data. As you probably know, Columbus won the DOT's federal Smart City Challenge in $50 million a couple years back, and now they are ingesting our data into their Smart Columbus operating system and finding some interesting things from it. So you look at something simple like road impediments. Well, I can't fix every pothole in my city, but I should prioritize the ones that I should be fixing. So you overlay that with demographic data from the Smart Columbus operating system, looking at age demographics in an area and accessibility issues, and you fix the ones that make sense. So some really cool stuff that we're doing there. Impact to our existing heavy-duty trucking community, right? Looking with truck parking locations is one of our data sets. Recently in May, there was a parking desert article that was released, how in Georgia, around Atlanta, there is this parking desert. And so we decided to look into our data. How does our data reflect on that? So sure enough, we would see at a specific intersections, we would see a Flying J, a Travel Centers America, a Love's. But wait a second, on the on-ramps, we would also see parking. And why is that? It's because they don't have a place to park. So this data set can be used from a policy perspective to help people figure out where they should be placing these parking spots by making data-driven decisions. So there's a huge impact, I think. New partnerships are being created. We are very, very excited. This is really only the very beginning of what we've got on data.geotab.com. Please attend the session that we have at 1 to 2 p.m. This afternoon. We'll be going to in much, much greater detail. But data.geotab.com is more than just these aggregate data sets. It's about providing more insight. There's sample code on there. There's white papers. We are also releasing, and we spoke about this yesterday, Bob and Dan had a talk, our new data science package. And data science package is phenomenal. It allows you to have your own data lake. A couple of years ago, Neil talked about the importance of having all of your data in one location. That's how you can activate on it. If you haven't done that, we have a data lake ready-made for you. All of this will go into Google Big. You will have an ecosystem very similar to what GeoTab has from a big data perspective for your customers. Curated data sets, all of our aggregate data sets, all of the sample code and white papers of how to do things, you will have access to this. This is meant now for some larger customers who do experience difficulty in dealing with the mass volumes of data, right? So to give you an example of how it's used, let's take the simple example, again, of a pizza delivery model, okay? I need to get my pizza to Bob in 30 minutes or it's free. Well, if my competitor is able to get it to Bob in 10 minutes, who do you think Bob's ordering from the next time, right? So it's optimizing that time to service metric. And we do a great job, if you're looking at it from a vehicle perspective, of understanding how long it took to get from the actual distribution center, from the pizza place to the actual customer from GeoTab's vehicle data. But what we don't have is that point of sale data from the time that somebody picked up the phone to the time it actually gets delivered. So bring in your point of sale data into this data lake. Amalgamate it, and now you have a true metric. So you can look at your thousands of locations across the US, and you can pinpoint which locations are doing well from time to serve metrics and which locations are failing. And these are easy queries to do once you have it in this data lake. You need all the data to be pushed into there. So please have a look on data.geotab.com. There's a section under there called Data Solutions, Data Science Package. Please sign up. If there is a larger customer of yours, or you are a larger customer that is interested, please do fill out the form on there, and we'll be sure to get something set up. We have new data visualization tools. Bernie and Gordana showcased a lot of that yesterday. And just visualizing data can help you make sense of it a heck of a lot better, right? Being able to dive deep into the data, super important. So all your My GeoTab reports that exist today that you've spent a lot of time customizing, making sure they're just right, you can use those as data sources in this new data visualization tools. And you can create all sorts of cool charts and widgets and zoom in into other areas of My GeoTab and to other dashboards that you've created. Very, very cool stuff. And it's all on the web, all the web editor. It will be an add-in and will be released very shortly. We'll make sure we keep you guys apprised of when that will be. It will be very, very short. And in all of this talk, I think we'd be remiss if we didn't think about the ethics side of things, okay? And when we talk about ethics and machine learning and AI and data, it's important that we just start simple. A simple question like, what can I do with this data? What am I authorized to do with this data? We have to start there. You know, in everything that we release through data.geotab.com, it goes through an extensive privacy review, a privacy committee, risk assessment. We make sure that there is a risk reward there, that we're dealing with multiple customers when we aggregate data, so not any individual customer or driver can be identified. We think about the misuse cases as well too. It can't negatively impact our ecosystem is hugely important. So when we think about ethics, it's in the way that data is used, but also in the way that the machine learning algorithms are learning to use the data. So there's kind of two stages, but at least start with understanding how you can use the data, what you have authority to do and what you should be doing. We will always do the right thing at GeoTab by our ecosystem. And that's what we build into our data governance models, into our data tagging ecosystem, and how we monitor our machine learning and this kind of thing. But let me give you an example of how that can come to question. What if GeoTab happens to know that there's a black eye situation there because an individual vehicle had its ABS activation go off? Do we have a duty to report that to the other vehicles around so that they don't fall into the same situation? Do we have a duty to the end customer not to divulge that private information? It's a dilemma there for us, and I don't have the answer to what that is right now. But these are the ethical things that we need to start thinking about as we build our ecosystem, and things that we are thinking about through the committees that we have established at GeoTab. And as I was thinking about ethics and machine learning and what we're doing, I ran across this really interesting video that I thought I'd share with you folks, because it talks to ethics and machine learning and AI as being something we need to start thinking about today, not 10 years from now. Because if you don't build in the ethics today, whose ethics are you building into the system? You need to really think about that. It's not an easy situation. There's a lot of fields of study going on right now thinking about how we can build ethics into our machine learning algorithms. So have a quick listen at this, and we'll see what you guys think.
There has been a kind of sea change in AI over the last 5 years. Before that, had you asked seriously whether or not we should be crafting a code of ethics for artificial intelligence? As we've seen AI begin to be applied in real applications in Facebook and in self-driving cars.
Now is the time to be talking about these issues. And we are the people who will be deciding what society looks like for our children in an AI and roboticized world.
Over time, software is going to be written by software. AI is going to create the AI. So
let's get a code of ethics that really prioritizes ethical considerations at the beginning of design. And that will help both the creators of the technology and then certainly the users, because there's a better sense of value alignment for the technology and the people using it.
There is no one universal set of ethical principles, so it will be already very important to try to identify the right values to be used in a particular scenario. And then once you have identified them, of course, you need to understand how to model them and how to embed them inside the AI system that you want to develop and deploy.
When it comes to a split-second decision that will potentially involve a necessary injury or death, and there are trades, what will an automatic car do? This brings to the fore this notion of ethical models in our systems, and whose ethics are they?
We create these technologies, and we need to choose how we want to use them, or otherwise we will be used by them.
This idea of ethics is really this glorious opportunity that we have as humans right now today for deep introspection.
The awareness and the intent by creators of this technology is to not be blind, to not ignore those negative possibilities, but to understand them up front, make the world aware of them, and do what we can to mitigate their impacts.
How do we represent our values in these systems such that the systems are aligned with us? They would make the same decisions we might make had we had a long time to think about it.
the power of these AI systems is going to be that they do infer a lot, that they will know us better than we know ourselves. We'll be tracked in a lot of different ways with some kind of underlying goal. Is that goal to sell us products? Is that goal to make us more educated, to make us more civil, more open-minded? It's potentially an indoctrination machine. And how that's governed, who runs that, is that going to be strictly for commercial purposes? That's, I think, one of the key questions. This is too powerful just to sell lawn chairs to people. This changes the way you look at the world. So it would be good if it were taken that seriously, I think.
How will machines know what we value if we don't know ourselves?
So some really interesting questions there that we don't have the answers for today, but that we need to really start thinking about as we develop these machine learning systems, these machine learning algorithms, the things that are foremost in our mindset at GeoTab. So how do you activate today? What are some of the things that you can do? So On the predictive maintenance side, have a look at the conversation today that will be had by the folks at Pepsi Frito at 11. Look at what we're doing from a benchmarking perspective. If you didn't have a chance to catch that yesterday, please do reach out to us. There's a number of us from the data team on the floor. We can talk to you all about that. It helps you understand not only benchmarking these vocations, classifications that we have, but how your business is changing and what tools that you can create on top of what we've already created to leverage and help your customers. Look at operational cost savings from avoiding these human interactions when Duplex is ready to go. Tie that in with the GEOTAB data. We're building AI on top of AI. What we're trying to do here at GEOTAB is really help you demystify all of this data. There's a ton of it, and we're building up our data team. You know, a year ago we were 7 people on the team. Now we're 25. It is a dramatic and a very, very important part for the GEOTAB ecosystem to be strong at machine learning, to be strong at the analysis of all this data so that we can help you and provide you guys with the right tool sets. If you don't have your data in a data lake already, get it into this data lake. We've got a ready-made one for you. And as I said, machine learning is only a small fraction of everything that you need to do. There is so much more beyond that. But we're here to help. We're poised to help. And partners and customers, I think that this is a really exciting time, and the trajectory for growth is absolutely incredible. So we're excited to be here for you and what the future holds ahead for everyone here in this entire ecosystem. So thank you very much for listening today. Without further ado, I would like to welcome to the stage the literal godfather of deep learning. This guy invented this stuff, just a tremendous guy. I'd like to welcome Geoffrey Hinton to the stage.
Okay. I'm going to try and do something today that you may not be expecting. I'm going to try and tell you how this stuff actually works. So how many people here know how the backpropagation algorithm actually works? Can you raise your hand if you do? Good. Okay. So you hear lots of stuff about this is the future and it's amazing and all that's true, but I think it helps to know what's actually going on. So I'm going to give you a more historical story about what happened in AI over the last 60 years and what this algorithm actually is that's causing all this disruption. So what's been happening for the last 60 years is there's been 2 models of how to understand intelligence. There's been the logic-based model, which all the fathers of AI believed in, where what you have in your head is a bunch of symbolic expressions, and you have rules for manipulating those expressions, just like a logician does, and that explains how you can get from some premises to some conclusions. And the good thing about those rules is you can get from premises to conclusions without understanding what you're doing. That's completely not how people work. That's my belief. The other alternative was that we have brains. They're clearly intelligent, and we should try and build intelligence by mimicking brains. And what goes on in the brain is you learn more or less everything, and you learn it by changing the strengths of connections. So these are 2 utterly different views of how to make intelligence. The second view, incidentally, there were 2 people who really believed in the second view, and they both died young. One was Turing, and the other was von Neumann. They're associated with symbol processing, but they really believed the biological view. So in the 1960s, the neural net people got wiped out. Symbolic AI just worked better. And that's because neural nets were trained just using a layer of handcrafted feature detectors, and then you decide on some weights to put on those. And that's not powerful enough. In the 1980s, we got this algorithm called backpropagation. Other people had thought of it in the 70s. We began using it in the 80s and showed it could do amazing things. But there was lots of hype, and it didn't work as well as we hoped. We didn't know at the time why not. And the answer we know now is we didn't have enough data and we didn't have enough processing power. In the 1990s, other methods like support vector machines and other machine learning methods, random forests, things like that, worked better than neural nets. And neural nets got wiped out again. Not in psychology, where people kept on studying them, but in AI, in computer science. In 2009, we got the first evidence that neural nets could be amazing at speech recognition. And since then, it's just been lots and lots of progress. And neural nets have done amazing things. So they've led to a transition from getting a computer to do what you want by programming it and getting a computer to do what you want by just showing it. Of course, you have to put some kind of program in, but the program you put in is a program that you can show things to and it'll learn. So here's an example of what people could not program computers to do. They couldn't program a computer to take an image like this and produce a caption. That involves all sorts of things. It's obviously a computational problem, but you have to go from millions of real numbers that represent the RGB values in the image to a string of symbols that are the caption. And if you think about trying to write a program to do that, you can have all sorts of ideas about how to do it, and people tried for 50 years to do that, and they couldn't do it. And we can now train systems to do that. And so I'm going to give you a sort of overview of how you would train a system to solve that problem. And we're going to do it in two pieces. We're going to first train a system to do perception, and then we're going to train a system to do language, and then we're going to put them together. So what's the system like? And this is, you can probably tell at this point that I used to be a professor, and I like explaining how things work. So we're going to make a system out of artificial neurons. They're much simpler than real neurons, but hopefully they've got something in common with real neurons. And what they have in common is you can put a whole bunch together and use a learning algorithm, and they will do amazing things. So the individual neurons we call rectified linear neurons. They take some input. That is, they have input connections. They have signals coming along those connections. On each connection, they multiply the activity coming along the connection by a stored weight, add it all up. That's their total input. And then they give an output that is 0 if the total input's below a threshold. And above that is just how much the total input is above that threshold. So it's just linear. So it's called a rectified linear unit. And the way they learn stuff is just by changing the weights on the connections. So we put those things together. The simplest architecture is a feed-forward neural net. You put layers of those things. You have weights at every layer. And when I change those weights that are shown with colored dots there, what I'm doing is changing the conditions under which a neuron will respond to something. That means I'm turning the neuron into a feature detector. When it responds, we say it's found its feature. When it doesn't respond, that's not the feature it detects. So basically, by changing those weights, I'm designing feature detectors. And the big change with earlier pattern recognition is, instead of hand designing some feature detectors and then just learning how to weight them to make a decision, we're doing this in multiple layers. It's now hundreds of layers in recent systems. And that makes for a much more powerful system that's much more flexible. The way we train it is we give it an input, like, for example, an image of a road, and we give it the correct answer, which is there's a pedestrian there, let's say, and we train it to say whether or not there's a pedestrian there. That's called supervised training. And we adjust the weights in the network to reduce the difference between what the network predicts and what the right answer is. So here's a simple example. Suppose we want to train a neural network to recognize whether or not there's a cat in a picture. We showed a picture of a cat at the input. We have multiple layers of feature detectors, many more than I've shown. And what we could do is we could take a bunch of pictures of a cat, put them through the network, and see how well the network does. Let's do it for just one picture. For the picture we put in at present, the network thinks it's slightly more likely to be a dog than a cat, because that output arrow for a dog is a bit bigger than for a cat. And we'd like it to think it's more likely to be a cat than a dog. So here's a really dumb training algorithm. This is what everybody who knows about evolution first thinks of as a way to train a neural net. What you do is you pick one of the weights and you mutate it. That is, you change it a little bit. And you see if the network works better. So we pick that weight, we change it. Okay, we changed it, we made it bigger. And look, the network works better. It now says it's a bit more likely to be a cat than a dog. So we keep that change. And then we pick another weight. And it's already saying cat's better than dog. And we change that weight a little bit. And cat's even better now, so we keep that change too. You can see how this goes. And you can see that it's not very efficient. In your brain, you have trillions of weights, about 10 to the 14 of them. And what we really have to do this is change a weight, change one weight, and then go through a whole bunch of examples to see if averaged over those examples, things are getting better. Because they might get better for one example and worse for others. And so you can see that just to visit every weight once, you're going to have to see trillions of images. Now, the bad news is you only live for about 10 to the 9 seconds. Actually, it's about 2 times 10 to the 9, which is important for me. And so you don't have time to do that. Now, you can see what we're trying to do. We're trying to figure out how to change all these weights so that when you show it a cat, it says cat. And what you'd like is to be able to run the algorithm I just said of fiddle with the weight and see if things get better. But you'd like to do it 10 to the 14 times faster. That is, you'd like to do it faster than that algorithm by a factor of the number of weights you have. And that's what backpropagation does. So in the evolutionary algorithm, what you do is you fiddle with the weight and you look to see what that does. And if you fiddle with lots of weights at once and look to see what it does, you don't know which weight was responsible. So you have to do them one at a time. But in backpropagation, what you do is you use the fact that you know all the weights in the network to send a signal backwards through the network so that you showed a picture, you look to see how the difference between what it says and what it ought to say, you send that difference backwards through the network. And now you can figure out for every single weight how perturbing it would make it say cat more strongly or more weakly. So you can do it all in parallel. And so for the kinds of networks we use that have 1 million connections or 1 billion connections, it's 1 million times or 1 billion times faster. And that's all there is to the backpropagation algorithm. It's just some calculus that allows you to figure this out. So people figured this out in the 1970s who did control theory. In the 1980s, we started playing with it and showed that it could do neat things. But that's all it is. So how come it didn't work in the 1980s? It worked a little bit, and it's doing amazing things now. Well, computers got a lot faster, about 1 million times faster. The data sets got a lot bigger, and we discovered a bunch of technical tricks. We think the technical tricks are very important, but actually they're not the main point. The main point is more data and more computation. So the first place this really made an impact was in speech recognition. So in the Android in 2012, the work that we'd done in Toronto in 2009 got developed further by Google, also by IBM and by Microsoft. It went into the Android in 2012, and there was a sudden jump in speech recognition performance. Suddenly, the Android worked better than the iPhone for speech recognition. The iPhone caught up again because they started using neural nets too. Then in 2012, for some reason, the work in 2009 didn't make a dramatic change. But in 2012, we applied it to object recognition because people at Stanford, in particular Fei-Fei Li, had put together a big data set of images that was finally big enough to train a neural net. So you've got 1 million training images, and there's 1,000 different classes of object. So you get 1,000 examples of each class, and there's a lot of classes. And there was a public competition with a private test set, so you couldn't cheat. And if you look at how well the teams did in 2012, that's the lower part of the slide, some very good computer vision teams used the best existing computer vision technology, and they kind of asymptoted 25% error. We used our neural nets, just 2 grad students, and we got about half the error rate, almost half the error rate. And that had a huge effect. Over the next few years, people developed these things further. And once you know a technology works, you can make it work much better. And so by 2015, the error rate was down to 5%, and now it's down to 3%. Now it's just slightly below 3%, which is about human level. That had a huge impact on the field. That's when Microsoft and Amazon and everybody else decided, hey, this stuff really works. So just to show you the kind of perception it could do then, ImageNet contained images like this, which is not a whole cheetah sort of nicely outlined. It's a close-up of a cheetah. And what's interesting is the mistakes it makes. So cheetah's the right answer, and it puts most of its betting on cheetah. But the other bets that it makes are all sensible bets. The same with that one. If you look at the slide, most of the slide's occupied by the roof and the building in the background. But it knows that because that's an image that's been labeled, the thing in the middle is probably the most important thing. And it gives sensible labels. And here's something from a catalog. Its first bet is not the right bet here, but you can see why it believes in things. If you look at frying pan, which was one of its bets, you can see that that looks like a frying pan if you don't have your glasses on. So it makes sensible errors. So then what happened next was something I really didn't expect. I didn't expect it to happen for another 10 years or so, which was people started applying this technology to machine translation in a way that seemed crazy. Because machine translation, if anything is going to be good for symbolic AI, it's going to be machine translation. Because the definition of the task is take a string of symbols in one language and produce a string of symbols in another language. At this point, I should point out that people in what I call conventional AI, symbols come in and symbols come out, and they assume that that must mean there's symbols in between. It's all symbols. I think this is utterly crazy. Symbols come in, symbols come out, but what goes on inside is not rearrangements of symbols. That's what logicians do, but it's not how we work. And I'll try and convince you of that later on. We work in a completely different way. Okay, so what we're going to do is we're going to try and translate from one language to another, not by the way Google used to do it, which is you store a big table of this phrase in French translates to this phrase in English. And then you look at the sentence and you find various combinations of words and see how they might translate. You get all these bets about what phrases you'd like in French, and then you stick them all together to make a plausible sentence. We're going to translate in a completely different way, which is sort of the naive way to translate, which is you listen to what's said in the first language, you understand what's said, and then you say it in the second language. That's very different from manipulating symbols or translating one phrase to another phrase by just storing a table of phrase to phrase. And so what you have to do is take a string of symbols coming in and convert it into the thought behind the sentence. So if you ask, what's a thought? Well, I can take any string of words and I can put them in quotes, and I can say, John thought, and then some string of words in quotes. So I can say, John thought it's raining today. But I can also say, John thought, damn. Or John thought, oh no, not again. Anything you can say, you can put in quotes, and John can think that. Which leads me to think that what a thought is, what you get when you process that thing in quotes. It's the internal representation. Of course, if I have an internal representation, which is a big pattern of neural activity, I can't actually tell you what that pattern is. It doesn't help you a lot if I say neuron number 753 has an activity of 1.2. That's not going to work because your brain isn't exactly the same. And the big activity pattern, I mean, we can do it between computers, but between you and me, that really isn't going to work. So what we have to do is refer to these thoughts by either giving you the sentence that would have caused the thought, or by giving you a sentence that the thought would have caused. So the fact that thoughts always correspond to sentences is not because thoughts are sentences, it's because you use the sentence to tell somebody the thought. Or if you have the thought, you turn it into a sentence so that somebody else knows what the thought is. So the idea is what goes on inside is utterly different from processing strings of symbols. And if you told someone this even 5 years ago, if you told someone you're going to translate this way, a linguist or a computational linguist, they'd have said you're crazy. There's just no way you're going to be able to take a sentence, turn it into a thought, and then take the thought and turn it back into a sentence in another language. It just doesn't work like that. You're going to need to know lots of linguistics. Well, it turns out the way Google translates now, they have neural networks, and these neural networks have no prior knowledge. They just take whatever language it is, they find the 32,000 symbols that you can make that language out of. So in English, the would be a symbol, but ing would be a symbol too. And so floating would probably be fl and out and ing. And they convert the input language into this string of symbols, which are words and pieces of words, basically morphemes. And that comes into the net, it gets turned into a thought, and then the thought gets turned back into a sentence in another language. Now, that's not actually true, what I said. It started off like that. It's now quite a lot more complicated than that. But if you understand what I just said, that's the essence of it. So I'm going to tell you now about recurrent neural nets. They're different from these feed-forward neural nets. I'm going to suppress a lot of the details. So the way a recurrent neural net works is you have input patterns coming in, one at a time. That's those input neurons at the bottom. There should be many input neurons, but I couldn't fit them on the slide. And those input neurons provide input to some hidden neurons, which may come in several layers. And those hidden neurons cause activation in some output neurons. And the important thing is that at every time slice, you use exactly the same weights. So if you look at the middle layer of hidden neurons, the weights that go from a neuron to the neuron, the same neuron at the next time slice, are always the same. That is, they change with learning, but for any given sentence, they're going to be the same as you process the sentence. So with a recurrent net, instead of activity just flowing forwards from input to output, symbols come in one at a time, or video frames, and inside the net, you're accumulating activity. So these hidden neurons are accumulating information about the history of this input. By the time you get to the end, they will have accumulated information about the whole sequence of inputs. And so to translate, what we do is we have a recurrent net. This is translation a la 2014 with neural nets. For each language, we have a net that encodes it into a thought, and a different net that will decode a thought into a sentence. So the encoder net might work like this. You take the first word in the sentence, or the first word fragment. You turn it into what we call a word vector. That's a big pattern of activity that captures a lot about the meaning and syntax of that word. That word vector then activates the hidden units. At the next time slice, you do the same thing with the next word, and you combine information coming over time from the previous state of the hidden units with information coming from the current word until, let's suppose it was a 4-word sentence. When you get to the end, that activity in the hidden units is the thought. It's not sort of like a thought, it is the thought. It's the thought that this network has when you feed it that sentence. Now, to begin with, all these weights are random. So you feed stuff in, and there's this pattern of activity, and it's a kind of meaningless thought. We're going to train all of the weights in this network purely by showing it data. So that's the encoder network, and we have to train the encoder and the decoder together because we don't know what the thought should look like. I could train an encoder network to turn word sequences into thoughts if you would show me thoughts, but you can't show me thoughts. You can just show me sentences that lead to thoughts. You can't show me these big internal patterns of activity. So what we're going to do is we're going to train an encoder and a decoder together. The decoder network is going to take a thought, and the first thing it's going to do is try and predict the first word that you use in the other language to express that thought. So if you're translating English to French, a thought will arrive at the decoder network that came from English. And the first thing we'll do is make bets on what the first word should be in the output sentence. So it's good possibility it's le and good possibility it's la. And since I'm at Google, there's a good possibility it's sha. And you take all the words you know, or in fact all these 32,000 fragments of the second language, and you predict their probabilities. And what you'd like to do is, given the thought that came from the English sentence, you'd like to have a high probability associated with the correct word in the translation. So what we can do is we can look at those probabilities and we can train the system by saying, make the probability for the correct word higher and the probability for the incorrect words lower. Then having produced this distribution, we pick the correct word and feed it in at the bottom. And so we say, actually, the first word was this. Can you predict what the second word would be? And it will now try and predict the second word. And it'll just give you a probability distribution. It'll give you over all 32,000 possible fragments, it'll give you their probabilities, a bunch of numbers that add up to 1. And again, you train it to try and maximize the probability of the correct answer. And if you want to generate from this system, you can just let it produce a distribution. You can pick from that distribution rather than picking the correct answer. Then you can feed in whatever it picked. You can let it generate a distribution for the second word. You can pick from that distribution. And that way you can get something to just generate sentences. And it'll generate all sorts of amazing sentences. In fact, now at Google, we've got very big networks that are trained on lots of language, and they can do amazingly good job of generation. But I'm not going to go into that. So the way you train this whole system is you take your encoder, it produces a thought. The thought goes to the decoder. The decoder then starts producing distributions. And for example, after you fed in the second word, it'll predict the third word, and you would like to get high probability for the correct word. And so if you look at all the arrows in this diagram, you could take that probability of the correct word, and you can go backwards through all those arrows, figuring out how to change the weights to increase that probability. It's just like we did before, figuring out how to change the weights so as to make it say more cat and less dog. Now we want more of the correct word and less of the incorrect words. And you go backwards through both all of the connections in the encoder and all the connections in the decoder, and you can train everything. So you can start with encoders and decoders that are completely random weights. You can just show it lots of pairs of translated sentences, and it will learn to translate. And my view is that's the end of symbolic AI. We took a problem that should have been solved by symbolic AI. If it was going to do anything, it would be able to do that, and it couldn't do it, not very well. And neural nets that learn from scratch can do much better. So it's important to use attention now. So the thing I left out there was, as you're producing the sentence in French, you look back at the English sentence. You have a sort of window of attention, and you get extra input from the English sentence as you're translating the French sentence. So it's not quite as clean as turn the English into a thought and then say the thought in French. You're looking back at the English as you say the thought in French. But I think you've given you a good feel for how it works. We can now combine that with vision. So when we were doing translation, you have an encoder that takes an English sentence, gives you a thought, and then you say that in French. Instead of the encoder, we could actually have the system for recognizing objects. And we could take the final hidden layer, just before you say what the object class is, you can take the last layer, which is representing what's in the image in terms of the kinds of objects that are there, and you can put that in instead of the thought. We might call that a percept. That's what you got from the image. So you put in a percept now, and you get it to say that percept. So the answer to the question, what does the neural network see? Well, you could sort of look at the activities of all the neurons, but you could also just ask it. It can tell you what it sees. Okay? And if you ask, how do I know what you see? Well, you tell me, right? Unless I go into a psychophysics lab, that's how I know what you see, and we can do the same with neural nets now. And so by combining this vision system with a machine translation system, but now something that's translating images into sentences, instead of sentences into sentences, we get something that can caption images. So here's an example of an image in the database. The system hadn't seen this image before. According to the database, a good caption would be a group of people shopping at an outdoor market. That's better than the system that Google had a few years ago. That system said people are crouched around in a, sorry, I got it wrong. The Google system says a group of people shopping at an outdoor market. So it realizes it's outdoor, it realizes a market, it realizes there's people shopping. It doesn't get the crouching. In the database that's used for training, or in this case for test cases, it says people are crouched around in an open market, which is a somewhat better caption, but you can see it's got the idea. And again, there's the problem we started with. How do you get from those RGB pixels to a caption? And hopefully, when I first said that, it seemed like a tough problem, and now it seems sort of fairly straightforward. You know how to do that now. It's just a question of a few technical details and a lot of computing. Okay. I'm going to conclude. I'm going to leave plenty of time for questions. I'm going to conclude, first of all, by telling you what a thought is, and then by giving you some speculations on the future. I haven't made any slides for speculations on the future, because if you look back in history at people's speculations on the future, they were ill-advised to write them down. Okay. So, I've said some of this already. A thought is a big pattern of activity in your head. Sentences evoke thoughts, but a sentence is not a thought. So almost all of the humanities, almost all of philosophy, and almost all of AI until quite recently, labored under the belief that a thought was something like a sentence. It was a kind of cleaned up sentence in some special logical language in your head that wasn't ambiguous. And you would operate on it the way you might operate on sentences. And I think this is complete nonsense. It's a religious belief that just isn't true. A thought is a big pattern of neural activity. Now, it'll turn out that that's complete nonsense too, but it's better nonsense than the previous nonsense. And that's all you need to make progress. That's called gradient descent. Let me just give you an analogy. Let's suppose that people came with dot matrix printers. Let's suppose you had lots of fingers and they had ink on the end. And so if you wanted to say what you just saw, you went like this. And you just printed what was in your head, right? That's what we do with language, right? We can take a thought and we can turn it into words. If we could take a percept and turn it into pixels, then what we'd have is pixels, that's called video out, which we don't have. It would be very useful. If we had that, it would be pixels coming in on your retina, and then pixels going out on your dot matrix printer. And philosophers would say, well, pixels come in and pixels come out, so it must be all pixels in between. Now, we know that's not how we understand images. We don't understand it just by manipulating pixels. When I look at a 3D scene and want to know what would happen if I were to walk around there, I don't understand that by moving pixels around. Some psychologists think you do, but that's nonsense. And I think what's happening is that people are making exactly the same mistake for symbols. They're saying symbols come in, symbols come out, it must be symbols in between. It's not like symbols at all. But the question is, what is it like? So let me show you what it's like, what I think it's like. What people are really good at is analogical reasoning, not logical reasoning. And here's the kind of reasoning people can do. And because you're adults, you know this is complete nonsense, but you also know what the right answer is. So if you have to choose between all cats are male and all dogs are female, or all dogs are male and all cats are female, at least in our culture, you don't have any doubt which way around it is. Probably because men are large and stupid and chase cats. and make a lot of noise. So logic can't really explain that. Logic is quite bad at explaining things that are nonsense. Analogical reasoning can explain it, and I'll show you an example of that kind of reasoning as done by neural nets. So what we're going to do is we're going to take a neural net and we're going to train it to predict the next word in a sentence, and we're going to give it lots and lots of sentences. I'm going to show you something from a long time ago, from 10 years ago, where we gave it sentences from the AP Newswire from the 90s, and it had to predict the next word. And it did it with a net that first takes the word symbol, then converts the word symbol into a big vector of about 100 components that represents the meaning and syntax of that word, so a bunch of real numbers, and then uses those real numbers to predict the real numbers for the next word via a neural net. And so the question is, what do those real numbers look like for a word? Well, they're 100-dimensional, so you can't really see them. I mean, I can plot out a bunch of real numbers for you, but you'd like to be able to see the pattern. So what we do is we take these 100-dimensional vectors that represent the meanings of words, and we try and find a way of mapping from 100 dimensions down to 2 dimensions. And there's a method called principal components analysis, which is normally used to do that. And the problem with that is it preserves big distances and doesn't care a hoot about small distances. We care about the exact opposite. We want to know which words have very similar meanings. If 2 words have very different meanings, we don't really care if they're a bit further apart or a bit closer together. What we want to do is make sure that words with very similar meanings are very close to one another. And so we invented a way of turning high-dimensional vectors into 2-dimensional vectors, so that if 2 high-dimensional vectors are very similar, their 2-dimensional vectors will be very similar. But if the 2 high-dimensional vectors are very dissimilar, their 2-dimensional vectors might be a lot dissimilar or fairly dissimilar. We don't care. And so let's have a look at the words that you get if you process news stories. First of all, I'm going to show you the 2,000 commonest words, and this is where they occur in the map. And this overview shows you that they come in clusters. These clusters must mean something. It's not kind of uniform. There's clearly clusters here. So I'm going to show you what's in those red rectangles. Let's start with the red rectangle at the top. It looks like this. You can see all those words are places. Now, remember, this wasn't told anything about places. It was just trying to predict the next word from the previous words. And what it's discovered in these vectors that it's learned just from the strings of words, just from the symbols, it's discovered that there's things called places. That is, a whole bunch of vectors that are all rather similar to one another, which all represent places. What's more, it's discovered a lot more than that. It's discovered, for example, that, is Toronto there somewhere? Yeah, there you go. Toronto is quite similar to Boston, and quite similar to Sydney. It's not so similar to Quebec. Quebec is similar to Berlin and Paris. It's much more continental. It's discovered that England, Scotland, and Wales are all very similar. If you look at the bottom, it's discovered that Vietnam and Iraq are almost identical, which could have saved people a lot of trouble if they'd known that. If you look at the top right, that's Cambridge. Underneath Cambridge, there's another word. It's obvious what the other word must be, but it's nice to see that Cambridge is on top. This is another one of those red rectangles. This is roles people play. It's discovered, for example, that there's people like authors and composers. If you look on the far right, there's legends. If you look at what's closest to a legend, it's a guitarist, okay? But if you look at what's second closest, it's an engineer. Okay. In the middle, you get all sorts of interesting words. So like tropical, wild, dark, deep, magic, and evil. I like that. And there's words that are clustered by their part of speech as well as by their meaning. So if you look towards the bottom left there, you'll see largely, primarily, mainly, mostly. So it's clearly got vectors that capture the meaning of a word. Now, once you've got those vectors, you can solve analogy problems just by using vector algebra. So basically by completing a parallelogram. So if you want to solve the problem Paris is to France as what is to Italy, what you do is you take the, you take the vector that represents Paris, and the vector that represents France, and the vector that represents Italy, and you complete the parallelogram. That is, you take the difference between Paris and France, and you apply that difference to Italy to get the fourth corner of the parallelogram. And then once you've got that fourth corner, you look to see which of the words you know is close to that. And it'll turn out it's Rome. Okay? So this system, notice what's happening here. It can do a kind of reasoning that people are good at, which is this analogical reasoning. And it did it without any rules of inference. And in fact, it did it with nobody telling it how to reason at all. It just tried to predict the next word in a sentence. It kind of lay there saying, I'm going to try and predict the next word by making vectors for words. And after doing that for a long time, it now automatically does analogical reasoning. And I don't think this has really sunk into the old-fashioned symbolic AI people yet. This is another nail in their coffin, because this is the kind of reasoning people do. This is the kind of reasoning that Trump supporters do, which in some circumstances is very unfortunate. But it's sort of the gut level of people. This is gut reasoning. And all that symbolic reasoning that people study, logical reasoning, is something that happens much later in people and is built on top of this stuff. But this is the core way we reason. Okay, I've got to the end of my slides. And before I take questions, I'm just going to tell you a little bit about the future, what I think the future's like, for about 5 minutes. But I want to start with an analogy, which fits in with my talk. When you drive at night, you typically drive using the tail lights of the car in front. And when the car in front gets twice as far away, its tail lights give you a quarter as much light. It's an inverse square law. And so you can get to, you get an idea from the fact that the lights are nice and bright, that if it were a bit further away, twice as far away, you'd still be able to see the lights. And that's all true if you have an inverse square law, which you have at night on a clear night. But as soon as you get fog, that's a completely different law. Fog is exponential. Each unit distance divides the light by a certain fraction. And so with fog, a car can be 100 yards away, and the taillights can be perfectly clear if you've got mild fog. And if it's 200 yards away, it's completely invisible. That's that wall that you get in fog. That wall is to do with an exponential. So when things are exponential like that, you can see very clearly for a short distance, and then you can't see at all. You can't, just because you can predict 3 years ahead, doesn't mean you can predict moderately well 6 years ahead. And so the question is, when is this wall? I think this wall's about 5 years away. I think we can predict fairly clearly what's going to be happening in the next 5 years. And beyond that, 10 years away, I think we have no idea. So that's my first prediction, which is whatever anybody predicts now, in 10 years' time, it'll be wrong. But in the short term, what's going to happen is computers are going to get a lot faster, and all of the applications are going to get a whole lot better, and there's going to be a whole bunch of new applications. So the technology we have now, if you just get more data and faster computers, is going to continue to do amazing things. It's not like the old days of AI where there was hype and we didn't live up to the hype. The hype is actually not hype, I don't think. I think it's real because it's in my cell phone. My cell phone runs on this stuff now. So we're going to see tremendous progress without even requiring any progress in the basic technology, the basic ideas. We'll have to have lots of progress in the hardware and collecting big data sets and storing big data sets. And that progress is happening. I think also there's going to be big changes in the basic technology. I think the way we do neural nets now, I can't believe that's the best way to do it. And one example I'll use is the function we use for a neuron is called a rectified linear neuron now. Most of the neural nets use those, the feed-forward nets at least. We didn't use that 10 years ago. That's a fairly recent thing. We used a different function for 20 years without realizing this other function worked quite a bit better and was easier to train. There's going to be lots of other things like that. So people who came into the field recently learn how neural nets work, and they think that's just how they work. They don't realize we just made it all up. And there's no reason why we would have got it right. I think there's going to be huge changes in the basic technology. And in particular, one thing I think is radically wrong at present is, in order to train to do object recognition, we need to give a huge number of examples. And that's because we deal with viewpoint by having training examples from many different viewpoints. We don't understand properly how to deal with viewpoint, or our neural nets don't. Computer graphics does understand how to deal with viewpoint. If you take someone in computer graphics and you say, okay, you showed it to me from that viewpoint, now show it to me from another viewpoint. They don't say, oh, well, I didn't train from that viewpoint, but my system can only do it from this viewpoint. You'd have to give me lots more training data for me to deal with another viewpoint. No, they just show it to you from another viewpoint, because they understand how viewpoint affects how the image looks. And our neural networks don't really understand that. Our neural networks are approximating, so that with enough data, they can model what's going on in the data, but they don't really understand how viewpoint works. I think once we understand that, we're going to be able to train with 1% of the data we needed before to train. We need hundreds of millions of images now, and maybe we can do it with just millions of images. And I think there'll be a whole bunch more things like that. I've been very surprised myself at the machine translation. I would not have predicted that even 5 years ago. It's working much better than I would have thought. So the main lesson to take away is the next 5 years it's going to be business as usual and things are going to get better. And after that, I have no idea what's going to happen. That seems like a fairly safe prediction. Okay, I've got time for questions now. There's a microphone. We're live streaming it. So if you could go to the mic to ask the question, that would help the people we're live streaming.
Geoffrey, I'm just going to join you on stage. I have a question for you. Thank you very much. It was a really great presentation. Thank you. So folks, while we're waiting for somebody to go to the microphone, I'd like to ask Geoffrey a question. This is something that's very relevant to everybody in the room. This is going to have a major impact on all the people, the folks here, autonomous vehicles. And so some of the press, some of the researchers have come up with adversarial examples of networks where taking the Google object classifier and adding noise to the image yields a result that's completely different to what was expected. And when you're trusting human lives to drive these autonomous vehicles around, and you don't necessarily understand how the neural network's processing and working, how do you see, do you think we're being a bit optimistic about the ability to put our lives in the hands of these autonomous vehicles? How do you see that all unfolding? What is your opinion?
So when I came here, I took a taxi, and I put my life in the hands of a taxi driver. And the reason I did that was just statistics. I mean, if it was really dangerous, they'd be killing people all the time. They only kill people occasionally. And I think for autonomous vehicles, if we were rational, all we'd want to introduce them is that they do significantly better than people. And you don't understand how people do it at all. We don't understand how people drive. Well, some people understand more, but basically we don't. We just let other people drive us if we believe they're okay drivers, and that's based on statistics. So I think for autonomous vehicles, it should be the same. Now, I do agree that these adversarial examples are very worrying. The fact that you can change an image imperceptibly and get the neural network to give a different answer means we really don't understand what's going on in it. I'm not sure we will ever really understand what's going on in these nets. There's trillions of weights in a big neural net, or there will be, and I'm not convinced we're going to really understand how it works any more than we really understand how people work. And I think we're going to have to do it based on statistics. So I'm very worried about regulators saying you're not allowed to have an autonomous car unless you can show me the program. That is, in symbolic rules, you can tell me how it works. And you can't do that for people. And I don't think you're going to be able to do it for these networks.
Very interesting. Thank you.
Hi. So my question is about the machine translation. I'm wondering how it deals with things like sarcasm, metaphor, and verbal tics. And if it can identify those, did you teach it to identify those, or did it learn on its own?
Okay. If it's going to deal with those, it's going to deal with those by learning on its own. The whole essence of this is you have these neural nets. They start with random weights. The only thing you do is carve up the language into little pieces, and you do that automatically too. It learns everything. Now, at present, it can do pretty good translations, but there's a lot it still doesn't understand. And I believe that's because the nets aren't big enough. In your head, you've got 10 to the 14 connections. In these neural nets, they only have of the order of 1 billion connections, 1 billion parameters, even with all their word vectors. So if you ask how big are the neural nets that do this machine translation, if you're familiar with brain scans, they have these little voxels, and a high-resolution brain scan would have a voxel of about 1 millimeter by 1 millimeter by 1 millimeter. And in human cortex, that would contain about 10 to the 9 connections, about 1 billion weights. So the neural networks that do machine translation are the size of 1 voxel in a brain scan. They're very, very small. And I think that's why they can't yet solve problems like the following. If I say the trophy would not fit in the suitcase because it was too big, and get you to translate that into French, it's important that you know that what's too big is the trophy, because the it has to have a gender in French, and trophy and suitcase have opposite genders. But if I say the trophy would not fit in the suitcase because it was too small, you know the it refers to the suitcase. And so the French translation now uses a different gender for the it. So to get the gender right for that it, you have to understand whether it's the trophy or the suitcase that's too big or too small. And to understand that, you have to understand that big things won't fit inside small things. That's just common sense knowledge about the world. And so you can't do really high quality translation until you know everything that a normal person knows about the world. And these nets are just much too small for that. So it's not doing that, and it's not doing sarcasm yet. And I don't think it'll do sarcasm for quite a long time. But I think it will in the end, and it'll do it by being much bigger and by learning from data.
Cool, thank you.
Any other questions? Maybe I've got one more question, Geoffrey, for you. Is there any research going on to go back to basics with the way that these machines learn, to maybe start again and think about how a baby learns and start from the principles of let's do edge detection, let's break up objects into separate objects, let's classify them, let's do lighting compensation, perspective compensation. Is that perhaps an alternative to maybe being able to then validate better a little bit more of an understanding about what's going on?
Yeah, so what you're describing is what they were trying to do in computer vision until neural nets wiped them out. And I think there's actually a lot to that. I would really like neural nets that implemented old-fashioned computer vision. And I'm working on that. But it's going to be a while before we get that working. One more question there?
Certainly. So right now, if I want to learn how to drive, or if I want to be able to get a driver's license, I have to take a driving test.
Right.
I have a set of circumstances. I got to turn left, I got to turn right, put on my signals, all that kind of stuff. So I would imagine that if we're going to be using a computer-based way of having vehicles drive, that we're going to give them driving tests. Now, we also know that there's competition. We know that Google's not the only person that's doing it. We have, probably 44 different companies that are doing this. So I guess it's like, how are we going to come up with the test and determine, is it just the marketplace? Is it going to be governments that are going to decide this? But what are your thoughts?
Okay, it's not an issue I've really thought hard about. It's not what I work on, and I agree it's very sensible to have tests. In fact, for a person, you have to do a separate test for each person.
Yes.
If Waymo, for example, gets a system that it wants to be licensed in different states, you can have a much more rigorous test that's much longer because you don't have to have a separate test for each vehicle, right?
No, of course not.
And so you can do much better testing than you can do for people. And obviously, that's what you want to do. And in a sense, that's what you're doing when you drive for millions of miles with these vehicles. That is testing. That is discovering what happens. So these vehicles are much more rigorously tested than any person is tested in a driving test. But it's not an issue I've thought much about.
Gotcha. Thank you.
All right, we'll have to wrap up there. We've got the fireside chat starting in a couple of minutes. But again, I want to thank Geoffrey. Great job, Geoffrey. Really appreciate it, giving us your insights.
Ladies and gentlemen, the wireless carrier fireside chat will begin in 5 minutes. Thank you.
Ladies and gentlemen, please take your seats. Our conference is about to begin. Ladies and gentlemen, please welcome back to the stage Colin Sutherland.
Hey, GEOTAB, day 2 at the afternoon, almost there. Guys backstage, there's water bottles by your chairs. This is great. So we're in this wireless connected world, and the wireless carriers play an increasingly relevant role for us in enabling connectivity to happen. So we thought, about a month or so ago, we said, do you think that our partners who are wireless carriers would agree to actually come on stage and have a chat? So this is a friendly fireside chat, and I'm going to introduce them and have them come out here, and we're just going to ask a few questions for about 45 minutes. So let me first bring on stage Mobeen from AT&T. Mobeen. Oh, I'm sorry. I'm gonna reverse it the opposite way. Mobeen, have a seat. Ken from Bell Mobility, Canada.
How are you? Thank you.
Thanks, Mobeen. Have a seat right there. That's great. You guys all shuffle around backstage. Mo Nasser from Sprint. Mo. Hey, Mo. Jose Manuel from Telefonica. Jose is in the house. Telefonica in the house. Balaji from T-Mobile. Hi, Balaji. Good to see you. And Mr. Clive Cawse, operations from GEOTAB. Clive's here to keep us all honest. Have a seat. Hey, Clive. So, pretty neat crowd, right? This is a fireside chat. It's all friendly. We're all family here. Everybody in the room's family. We're all family here. And you know, one of the things that when we started putting together this panel, I'm just going to go this way so I can see you all, that we're just entering this phase right now in the wireless carrier world. We went from, gosh, I'm old enough to remember Mobitex and having all those Mobitex devices out there, and they all, you know, went dark on us. And we had to upgrade to 2G and then to 3G and now to LTE. So really the question for the panel is, like, why are we doing all this? What is the importance of all these upgrades in the carrier? And for the crowd that's here and that will be listening, where does it end? Where do we see this upgrade cycle happening? So maybe we'll start with you, Mobeen. You just give us an idea of the importance of upgrading and
yeah, I mean, just like any other technology life cycle, network technology has its life cycle as well. So, you know, all of us have gone through that based on the requirements of the customers and the evolution of the demand and what our customers are looking for. But if you look at it from a larger context of IoT, only, you know, depending on who you talk to, no more than 10% of IoT traffic actually is going to go on cellular. So 90% of that traffic is going to go on to some other form of network, whether it's home networks or, you know, short-range networks and so on. So we believe, and also within the cellular network, you have now a myriad of technologies, right? You have low power technologies like LTE-M and narrowband IoT. You have LTE, you have 5G. So as we look at our customers and when we talk to our customers, we not only look at how we service them from cellular or 2G or 3G or 4G or 5G, but also how we address their needs from a variety of cellular technology. So I would say you can design a solution for 3 to 5 years, maybe 7 years, but it is difficult to see so far ahead to say how the needs will evolve. And then I think just like any other technology, we will go through these life cycles. There's no way to get rid of them.
Ken?
I would say, I mean, all the carriers are trying to keep up with the demand that as things evolve on the mobility side. And what you're seeing now is, when it comes to our, for example, Bell's backbone, we're doing gigabit speeds on the mobility network. And that's really to provide the bandwidth required for a lot of these mobile devices. And now when you look at the legacy solutions like 2G, they have a certain cost model, as well as they are being slowly replaced by new applications, new demand, and the carriers need to evolve how they're leveraging the spectrum and how we're servicing customers. And it's important for us to offer these technologies across all our points of presence across the country, because coverage is king when it comes to mobility. You need to provide the best coverage possible to enable the customer's applications. So we are very experienced at helping customers migrate, because we tend to identify every single SIM that you have that's going to be affected and where they are in the regions, and we try to help customers with that migration. But we know migration is something no one wants to go through.
Yeah. And Canada migrated earlier, as I understand, to 3G versus the United States. So the United States held on to 2G a little longer than Canada, and we were a little ahead of the curve here. So not all countries in the world upgrade at the same time, and I'll get to you, Jose Manuel, in a second on that, because 2G is still alive and well and kicking in places like Europe. So Mo, you're one of the carriers on the panel. I think you're the only one that's 1X RTT, right? So
So we have a generational change as well as technology change that has taken place. But I think if you think about, and this is not just for telematics, it's across all of IoT. It's the business need. So when we looked at what's the evolution path for all the handsets, it's more data, more faster speeds. While on the IoT side, I always talked about IoT as bursty, not thirsty. We don't need a whole lot of data, but we need a lot of bursts. So the operational changes are very different, and the spectrum is very different for IoT devices versus a phone. And that's why you saw in 3GPP this bifurcation take place, where a lot of the handset type changes were for Cat 6, Cat 7, and Cat 12, higher speeds, while in IoT it turned more towards Cat 1 and NB-IoT, because you needed to have those devices have lower consumption of power, because you want them to last longer, and you want them at cheaper prices as well. So the module prices went down. So that's really what's driving it. What's driving it is it's economics, because the device, you're going to pay $600 or maybe even $1,000 for a handset. For an IoT device, you're not going to pay that much. So you want your modules to be less, and that's what's really driving. And you want higher or longer battery life. And you do that by going into LTE Cat 1 and ultimately NB-IoT, where you have 20 years of battery life. That's really what drove the standard behind it. And we at Sprint are, we've launched, of course, Cat 1, and then Cat M is moving along as well. That's the path for IoT. And we see that it might actually get even more and more. Mabin mentioned that there are multiple technologies that are coming through, but NB-IoT is going to be in a position where the module prices are going to be maybe less than $2 to $3.
Wow.
So
that's impressive. Jose Manuel.
First of all, I would say that cellular networks are in constant evolution, smarter, stronger, faster, and at the end, better to fit our customer needs. So we are moving from 2G, 3G, 4G, and now the hot topic is 5G. That will bring us a great benefit for us, and specifically for the mobility space. And to make this happen, we need to discontinue all the networks, older networks. In the case of 2G, where we are, as you know, we have operations in Europe and LATAM, it's still available, but the reality is that we are minimizing the investment in the 2G, and we are actively promoting other technologies like 3G, LTE, and for sure all the connectivities around the LPWA. And in fact, if I have to put Telefonica as an example of what we are doing internally, is we are selling GEOTAB devices with 3G technology and not selling 2G. So that's, I think, a clear position.
Yeah, that's interesting. And there's a certain size or mass of current subscription base that already pre-exists that when the network says, I'm going to have a forced upgrade or an end of life something, it causes you stress too. Nobody wants to have 4 million customers that have to remove and replace, right? So these are big corporate decisions when we have to do it. So obviously it's not just a convenience factor. There are major impacts commercially to your networks to preserve, keep customers happy.
Yeah, no, I think that's right, Colin, because I mean, that's kind of the decision that we as T-Mobile went through a few years back. So we have a fairly substantial base of 2G customers, so we want to give them enough time. So we have the 2G network up until the end of 2020, such that as you make choices about these technology transitions, you can make an informed choice about where you want to go. Because to the point that was raised earlier on, I mean, there's CAT-M, there's NB, there's CAT1, CAT4, all modules available. You got to right fit yourself depending on the use cases. I mean, like if you're an asset tracking that is not pinging the network frequently enough, then maybe NB is your choice. On the other hand, if you have a high definition security camera that's streaming, then you may want a CAT4 module. But as we evolve the technology, we just want to make sure that the solution providers have enough time to think through the transition so they make the right choice. And LTE is here to stay, right? I mean, we all know that LTE is going to be here for the foreseeable future.
Yeah, that's good. Clive, so when a network does a network upgrade for us, it means we have to change a SKU at GEOTAB. So at GEOTAB, how do we handle, or how do you handle, what is that our world like in our organization to keep up with changing standards, changing network upgrades, and how do we cope with that in our company?
Yeah, so Colin, it's a huge challenge for us. I think we're a little bit luckier than some of the guys that have, a device in a meter that they're monitoring. Our devices, luckily for us, if you look at our competitors, most of the devices that they install are wired. So I think, the fact is that ours are easily removed and replaced, gives us a certain advantage. I think from, GEOTAB's perspective, we've got to work closely with the carriers. We've got to adopt the technologies as soon as possible so that we can minimize the fallout down the line. I do think, as you guys have mentioned, LTE is here to stay. And that is the future, and it's going to give us a long runway, to have these devices in the vehicles. A lot of our customers, only replace vehicles, 7 to 12 years in some circumstances. So we've really got to future-proof. As you mentioned, 2G is still available in Europe. So the type of technologies we're looking at, as we deploy into LTE markets, is to adopt the technology as soon as possible. But also look at some of the other use cases. I mean, Mo, you mentioned that LTE, specifically on narrowband, have got different applications. And that's very exciting to us because now all of a sudden, we can start connecting pallets and devices we wouldn't connect ordinarily because we've got technology that with 2 Penlight batteries or 2 AAA batteries can last years. So the use cases are coming, are going to explode on us in the future, which is very exciting for GEOTAB. But I think, future-proof, so we look at some of the LTE technologies that are coming out. We do have some LTE technologies with fallback, 2G fallback. So again, we want to consolidate our SKUs, have one product that services international markets, and I think with the technologies coming in LTE, that's giving us that opportunity.
When I hear, and Mo, I think you mentioned the word spectrum. And I'm going to start with biology, I'm going to work down the line that way. Spectrum is something that you all understand. It's nothing that anybody in this room understands, I promise you. So actually, in some of your CEO's messaging, he's talking about spectrum or 5G being a competitive advantage for your organization. So can you just translate for real world salespeople's language so I can understand what is spectrum and what's the impact of spectrum? And I can't cope with 5G in my lab. Right now I'm working on LTE in our MTM, but forget 5G. Let's talk about spectrum. What does it mean, and then how do you cope with that as an organization?
Yeah, I mean, as you all know, it's the invisible airwaves that you spend billions and billions of dollars to buy. So one word definition of spectrum. But let me kind of take it apart a little bit, right? Because it's not just about spectrum, right? When you think about what you experience as a customer in terms of throughput, latency, and all those things, it's probably three factors that go into it. One is the amount of spectrum that you have, which is the more you have, the better, because the more data you can carry. The interesting thing about spectrum is there are two different types of spectrum. There is the low band spectrum, and then there's the mid and the high band spectrum. And why that is relevant is what low band provides is propagation deep into buildings and spaces. High band helps carry more data load, right? So that's the spectrum part of it. And then you have the density of cell sites, which is how many cell sites do you have to cover the population, which is also relevant because the more dense your grid is, the more data they can carry, especially in dense urban areas. Right? And the third factor, I know you didn't want to go to 5G, but I'll go there because it's the technology, right? You got 2G, 3G, 4G, 5G, right? And as the Gs go up, the assumption is the efficiencies go up. So for a given spectrum and a given density of cell sites, you can carry a lot more load when you're in the 5G area versus when you're in the 2G area. So that's sort of the three big factors that are kind of interplaying in terms of how we as operators think about how we want to optimize the assets we have provide the best experience for our customers.
Yeah, so it translates in my world, and I think in a lot of people's world, it's how many bars have you got. So you're inside a building right now, I would look at my phone and I would know if I have coverage or drop calls.
Yeah, exactly. How many bars do you have, how fast your download speeds are, how low latency your communication is to the network. So all these three factors play a role in defining that experience.
Yeah. Jose?
Yes, I think it's a perfect explanation. What I would add is, at least for Telefonica, it's a nightmare, the spectrum, in terms of, I think that the main challenge is the disconnection between the business and the auctions. So when I'm saying this is because the business at the end, you have consumers asking or requesting to download more and more and more gigas for the same price or less. And then we have on the other side of the story, governments asking for very high price for the auctions of the spectrum. So that's one of the main challenges. And this is linked also to the sunset of networks, no? Because at the end we need to optimize the spectrum we have because it's a relevant asset for us. And we need to optimize and follow a strategy around the different networks. Just to put an example, we have an investment of an average of 1 billion per year in spectrum. So you can imagine the amount of money that it means for us, no?
Yeah.
No. So for us, for Sprint, as you know, that's one of our largest assets. I believe in the United States, if not even the world, we hold the largest spectrum of assets that we have, whether it's in 800, 900, and then 2.4. We believe that this spectrum holding is really going to enable us to be one of the first carriers to get into 5G. And really 5G is about the longevity and 5G is about IoT. So when we talk about IoT, all the stuff that was mentioned yesterday concerning the vehicles, the self-driven vehicles and all of that, 5G is about two things. Right now I'm still trying to wrap my head around it, but there's two things that are glaring right now in my mind. One is from the handset perspective, it's high speed. A lot of high speed data on the handset. There's going to be massive MIMO type, technologies that's going to allow us to go into the giga speeds. That's one. But the other side, which really comes with 5G and the whole densification thing with Magic Box, one of our products that we put out that we densify our network, is latency. And latency is really tied hand in hand with IoT. So when you have a self-driving, autonomous driving vehicle, you want to be able to send those commands and communicate back to the cloud in a real-time or near real-time approach. So you're talking about less than 10 milliseconds of latency in order for you to simulate true, real-time. Another application would be in robotics. One of my products that we put out is called Pepper. I don't know if you've seen it, the little Pepper robot. But if you see Pepper right now and you want to simulate a human, right? We talked about AI. If you throw a ball to Pepper right now, it's going to go it's not going to get it. And a lot of it really has to do with the latency that exists today, which is somewhere between 70 to 80 milliseconds. You need sub 10 milliseconds in order for you to emulate what a human being can do, and that's what 5G is going to deliver. So we're laser focused on 5G, on latency, which will enhance, we believe, IoT across many different segments.
Yeah. And just to build on that, I mean, two points. One is, the bandwidth piece is really important in terms of reserving the right spectrum so you can enable these new applications. But it's also about the network that brings all that traffic back from all those towers across the country back to your own core networks and to basically our service provider databases. And so having basically a fiber network that connects all these nodes is really important. In our case, we've got 85% of our cell sites that are linked with fiber and therefore well positioned to have tons of bandwidth when the 5G phenomenon starts hitting in a big way. Luckily for us, I mean, we're hitting in gigabit speeds right now with 4G because we're bonding channels together. And so our need to jump to 5G is a little bit delayed, which is great news for everyone because that means it extends the lifespan of LTE within our network. And also, another point about spectrum is there's really two buckets of spectrum. There's the public spectrum and there's the private spectrum. And there's technologies on the wireless side that leverage the public spectrum that are getting out there nowadays. More on the carrier side, we're more into predicted service availability for our customers. So we tend to aggregate and buy up private spectrum that we can count on being there. But public spectrum is out there and providers are providing solutions on it, but again, there's a little bit of uncertainty around what may happen to your service and will it be available in all regions across Canada, and should you invest in those types of technologies?
That's interesting.
Yeah, let's look at that question from the lens of a fleet solution, right? If you look at your GEOTAB customer 7 years ago and the profile of that customer and what they did and what they used fleet for, and if you fast forward and look at that customer 5 years from now, it's a drastic difference of what all the sensors, the data that you're going to read, and the kind of expectations these customers will have from the network and from the technology. And so I think Balaji mentioned that spectrum is one pillar of providing those services that our customers are demanding. So coverage versus capacity, spectrum, very important. Latency, very important. So all of those things translate to network evolution, your first question, and around having more and more spectrum, because regardless of what we provide, there is demand for more data coming off of these sensors, off of these devices. So the spectrum is required to do this, especially when you get into diagnostic data coming off of the cars in real time, when you start to get into LiDAR data coming off of these cars, when you start to get into video coming off of these cars, that means there's a demand for real-time capacity. And if Shannon's law says that you need more spectrum, so you just need more spectrum.
Yeah, I mean that's absolutely true. When in Canada we pay, I think I'm not going to put you on the spot, Ken, for all of Canada that might be here saying, why do we pay more for cellular costs in Canada than any place else in the world? I don't know if that's an over-exaggeration. I think we are like number 1 or number 2 in the world. But there's a trade-off, right? So there's price and trade-off. It's not just that we're in Canada and there's an inflation factor on the Canadian dollar. We pay about $5 a gallon for our fuel, and obviously it doesn't cost that much in America. It's just not currency. There are fundamental infrastructure investments that the Canadian carriers have made in uptime and spectrum and latency that I don't believe some of the other carriers have made. Right? So there's that trade-off. And what I'd like for you to each have an opportunity to talk about is what my concern is. As a consumer of cellular technology, I'm afraid that we think of the carrier that we buy as purely a commodity. There's no value add except for how many bars I get in my phone, or what are the drop GEOTAB devices, and where are my holes. We look at footprint and coverage maps, yeah? So my concern is that is kind of the role that the wireless carriers painted into that court. And I want you to be able to express, like for yourselves individually, how would you differentiate your individual network to a audience in the IoT space. You know, why would you buy one carrier over another? What is it that's unique about your specific carrier that would be a buyer awareness factor, right? So we can go and educate these people and become more educated buyers. This is not price. I don't want to shop on price. Yeah. Mobeen, sorry. Yeah, you want to kick off and go back down this way? Yeah.
So, on the carrier side, customers are not looking for just a network solution. Just, you know, from an IoT perspective, a lot of us sitting around here are involved in IoT, in fleet solutions, and carrier the network pieces are just one piece of the technology, right? So a lot of us are engaged in solutions where customers are looking for the right device, the right price, the right integration, the right services. So we look at it, when we engage with the customers, we engage with them with that in mind, not just network services. And that's why we put in partners like yourselves, where we don't do everything, but we like to bring in the right partners to help us either provide applications and services or to provide professional services to implement those solutions. So yes, it's AT&T branded solutions or Sprint branded solutions or Telefonica branded solutions or Bell Mobility, but we are building these solutions as AT&T branded solutions, but with the help of a lot of our partners.
Yeah.
So two points. You made a comment about Canadian networks and the pricing there. I mean, we have the privilege of being in the largest country in the world with one of the smaller populations in the world, and you know, our mandate really is to cover as much of the population as possible. Our network covers more than 99% of the population, and right up into the upper rubber boot of our various provinces, and unfortunately that costs money to deploy and to service, and that's one of the major reasons why you see a big change in costs and so on. But on top of that, back to Mobeen's point, which is bang on, our future is not about selling bandwidth. Our future is about selling content, applications, services to customers to enable their businesses. And so whether we do that directly through ourselves with solutions that we might sell directly to customers or through channels, we bring products and services to the table that they can help enable their businesses. My vision of where we are going in the coming years is more service providers are going to become more than a one-trick pony. Right now, customers have maybe 10 IoT applications within their business, everything from point of sale to security to fleet. And they're going to say, well, why do I want to manage 5 different or 10 different vendors? These are my preferred vendors. I want to buy these applications from them. And so service providers like ourselves will have to embrace those channels, help enable them with those solutions, and help them go to market.
Yeah.
So 3 points that I want to talk about, because when we talk about an IoT solution, you look at the value stack, right? You've got the network part, you've got the middle layer of device management, and then you have the applications on top. And really, you have to tackle them on those 3 levels in order to show value. We definitely don't want to be the dumb pipe. Nobody wants to be the dumb pipe, right? We want to show the value. And I believe the value comes in these 3 different layers. I mean, there's more, but if you just focus on the major ones, we talked about the spectrum, but sometimes we don't talk a whole lot when it comes to the network about the core network. Because the spectrum is your big funnel where you bring in everything else, you know, all of the signals coming in. But then you have your core network that aggregates everything. So one of the first things that we're doing is that we are separating all of our IoT-based devices into a totally separate core network. So you have your phone network, and then you have your core network for IoT. Just strictly because we are seeing the devices need special needs. They need SLAs, they need security, they need all types of things that are very specific to IoT. So that's one. And then the second part is on the device management, or sometimes called the IoT OS, the operating system for IoT. This is where you need to have the flexibility of having a global SIM and security all the way down to the hardware, and that's why we're utilizing one of SoftBank's prizes, which is ARM. So ARM, of course, is owned by SoftBank, and they are big on security, as you know. So we are working with our sister company, ARM, to ensure that we have security all the way down to the chip level. It's not just on the network side, it's all the way down to the chip level. That's where you add major value onto IoT. And then the last part is on the application side. This is where the ecosystem comes to play. This is where our relationships with companies like GEOTAB really, we go to market together. So we're going to go and make sure that we have the best partners going forward so that we can service our customers. So you have the core network, you have the middle layer with the IoT OS, and then the applications. It's really all about partnerships, because still IoT, you cannot do it on your own. You got to use the ecosystem.
Great.
Okay, in terms of IoT market and our proposition, I would say that we are taking really serious, of course, the IoT industry and putting a lot of effort. We are following what we call our IoT path. So first of all, and it links with the previous comment, is first of all, we have our networks. We have 16 operations across the world. So it's to manage a real complexity that also help us to have a global reach, especially in Europe and LATAM. The second one is our managed connectivity platform. This is an in-house platform where we have a clear proposition. The third layer for us is all the applications, and for us, GEOTAB is relevant for us because it's a strategic partner in the mobility space. We have different verticals, sometimes in-house solutions, as can be in retail, as can be in energy propositions, but sometimes relying on a leader, on a third party, like can be the case of GEOTAB for mobility. And for us, the last layer is the big data, analytics, where we are also putting a lot of effort and investing, acquiring companies, and that's our path, our strategy that we are bringing to the market through a very specialized team. But this is very B2B driven today, and I would like also to mention that the future is about B2C, and the way this is going to boost and convert really billions of devices connected will be from the consumer side more than for the B2B side.
100%.
Well, let me first start by saying that we called ourselves the uncarrier, so we kind of differentiated ourselves from the carriers. I think that there's some truth to it, right? I mean, when we started the uncarrier journey about 5 years back, it was all about listening to customer pain points and trying to find ways to address them. It's been remarkably successful for us. We've added about 1 million customers every single quarter for the last 20 quarters. And that still translates, as I mentioned before, keeping the 2G network up was a result of that, right? Because there was a lot of pain points from customers, and they spoke to us and we said, well, you know what, it's going to be painful for us because we're not actively using the network other than for M2M and IoT devices, but we decided to keep it up anyway. So a part of what differentiates us is that ability to listen to customers and react to what they want, right? Because that's important. Now, just like in real estate, it's about location. As in the carrier world, it's about network. So I cannot sustain myself as a carrier if I don't provide the network experience that is required. So we obviously have to invest and grow our LTE network. We've tripled our LTE network over the last 3 years and cover over 322 million POPs, and that's table stakes, so we've got to be there. We've got to have the network to support the value proposition that we have. And the third element that I would bring up is partnerships, right? That's key. I mean, we have a partnership with GEOTAB. That's absolutely key. And then we announced a partnership with Twilio to get after the developer community. Because in essence, what we have to realize is we can't do everything ourselves. I mean, especially in this IoT space, there are far more innovative people out there. And we got to find a way to reduce the barriers for experimentation such that that innovation happens. And for us, that is through partnerships. Finding the right partners, going to market in the right way, and building that ecosystem up.
Yeah, in a lot of ways, we call you wireless carriers, really either wireless solution providers, or beyond that, the fleet world is looking at mobility as a service. So the fleets are changing from fleet ownership to something different. And the carriers are doing the same thing. Mobeen, you maybe want to talk about that at the end of this line here, but I'm going to go to Clive for a sec. So I'm going to let you, one last question, we'll just go down the line. I want you to allow yourselves to blue sky. So where is all this going? What do you think 10 years from now? Clive, I want you to talk about what excites you right now. What's on the horizon? You don't have to tell the audience what we're launching in the next 2 to 3 years, but you can see at the chip level. And what do you see that's exciting, and where do you think GEOTAB might take itself from a new products perspective?
Yeah, so Colin, I mean, GeoTab's mission statement is to become a platform, and a platform in the industry. We see ourselves not just as connecting vehicles, we're moving outside of vehicles now into wearables, tablets, phones, and we'll expand. We'll expand sensors and we'll grow that. What's exciting for me really is with the introduction of LTE, I think we've moved past the point where we've got a long runway, which is very, very exciting. For the first time, the carriers and the technology is actually playing down into M2M or IoT. So, we've got IoT devices that require high bandwidth. But essentially, most of the focus is really on small packets of information that can be sent. And what's exciting to us is with LTE moving in and down. So typically, it was a race to get faster and faster with Cat 4 and Cat 5 on LTE, but you're seeing it push down into our space. And that does pose a challenge, and I'll talk a little bit about that challenge. But the advantage now of, let's say, Cat 1, it's got much more penetration, so we can get down mine shafts. We can now connect devices that ordinarily we wouldn't connect. You talked about spectrum, which poses a little bit of a problem. I think what's exciting to us coming down the line is in the Cat 1 chipsets, Cat M1, there's multiple band support. So you mentioned spectrum. Well, that translates to bands. Big problem for us is as we grow into the international markets, is to cater for all the different networks and whatever spectrum you guys have acquired over time. I think Cat M1 gives us the ability to create a single product that can, it's an international product. We can deploy one SKU internationally, which is extremely exciting for us. So there's all sorts of cost benefits that come along with that. I think as we move into narrowband, it's even smaller amounts of data, better penetration, and even lower power. And the exciting thing for me is over the next 10 years, there are use cases that we have not thought about. We talk about GeoTab being the platform and connecting devices. I can tell you it's going to be super viable to connect a pallet because the price points that we can get on narrowband are a couple of dollars for the module and the technology. So now all of a sudden you can come up with a throwaway device that lasts years, you plug it onto something and you can monitor it. And I think there's a whole lot of exciting times ahead of us where we haven't even thought about the use cases in terms of what we can connect and what data we can consume in our platform. So for me, that is really, really exciting.
That's great. Algie.
Yeah, just building upon that point, right? I mean, narrowband, it's here. We will have a nationwide narrowband network by the end of July this year, covering about 320 million POPs in the US. And what that does, I mean, yesterday somebody mentioned that everything will be connected. I think that's what it does. I mean, when you drive the price point and you drive up the battery life and provide the ability to connect everything will be connected, not through 10 different hops, which is what is happening today. I mean, I experiment with a lot of things inside my house, so I have all these cameras and everything connecting to a central hub, which then talks to my Wi-Fi router, which then talks to the internet, and by the time all of those things happen, there are like 10 different points of failures introduced into it. I'm not talking about that. I'm talking about taking a light bulb, and it's already working, and it's already connected to the network. I mean, and so that people who are actually building applications don't have to worry about how to connect that thing to the network anymore, right? So that's what things like narrowband is going to enable, is drive up the adoption in terms of what can be connected, and that opens up a whole host of use cases. As I mentioned before, I don't think we can figure it out locking ourselves in a room to say what is the best application that's going to come out of it. I think the best thing we can do is expose that out and let the smart guys, which are 4 people in a garage, figure that out.
Well, we are really optimistic and excited about the future in 10 years. Telefonica is a company with 94 years. We are here to stay. We are absolutely conscious about the transformation of the industry, of our industry. So we have been working really, really hard in the last 6 years in our digital transformation. We are changing a lot of things. And we have been working when the company started to connect homes, then to connect people in mobility, and the next thing will be things. So we expect an hyper-connected world where the car will be a key part of these millions of things connected, and for sure it will be the next space to be conquered. To do that, for sure we need, as you were mentioning, all of you, we need the right networks, but also the right offering, but also the right regulation to make this possible. And for me, something critical is to be a transversal opportunity, B2B, but also B2C. The future is coming from B2C to have this opportunity really, really big.
Like the last mile for cellular wireless. We talked about last mile yesterday. A UPS delivering a package to your doorstep's the last mile. So B2C is really connecting all the way down to the final end user. B2B is what we do right now.
Yeah. So for me, in the next 10 years or so, I really hope that IoT will deliver on its promise, because we see IoT as a technology that is really changes the way people live, the way companies operate, and the way societies evolve. And I think Neil hit it on the head yesterday when he was talking about how what you are doing in telematics is saving lives. And really that is our driving factor, is how would we take IoT to enhance the lives of people, to enhance how companies operate, and how societies evolve. That's what I'd like to see in the next 10 years, and then I will retire.
Yeah, at Bell, I would concur with that vision. I mean, we've been doing things to position ourselves for this. We're the largest media company in Canada. We're the largest ISP provider in Canada. We provide the most intelligent signals, and we're positioning ourselves to be able to help customers integrate not only networks and technologies, but with applications and content. And what we're going to see more and more is not only newfangled devices, whether it's an intelligent lawnmower or a smart light or what have you, being able to talk to the network, but we're going to see that integrated into the way people live their lives and conduct their work. And for us as service providers and solution providers, it's all about enabling customers.
That's fascinating, Ken. So yesterday morning when Neil was doing his keynote speech, we had some guys driving in from Fleet Karma from Waterloo. They got stuck on the Gardner Expressway up front. They were watching Neil's keynote speech streaming on their phones as they were coming in. So that's really what you're talking about. And they said it was seamless. It was brilliant, awesome, and they didn't miss a beat. So that's the kind of interconnected world I think you're envisioning. It's actually happening today. So 10 years from now, it's going to be even
hopefully no distracted driving.
No, he was the passenger, right? No, right. So in the future, he will be driving. He'll be watching and streaming on his.
Save lives.
Yeah. Mobeen, talking about multimedia.
Well, IoT obviously is very prevalent in our homes, in our businesses, and we're still at the beginning stages of this. But looking at it from the businesses that most of us represent here around things on wheels, we have 41 million devices on our network today. Over 20 million of those are things on wheels. And so if you look at it from that perspective, transportation, vehicle solutions have led the way of IoT. And I think over the next 5 years or so, it will continue to lead in all the things that we're doing here is what's going to pave the way for other things to get connected. Whether it's asset solutions or health solutions or home solutions. So I think transportation industry and vehicle solutions are at the bleeding edge, and I see that continuing to be at the bleeding edge of IoT.
I couldn't agree more. I just want to thank you all for joining us. This has been really fun for us to have you all here, and you're really great partners of ours. All of you equally are amazing partners representing Europe and North America, United States, Canada, and Latin America as well. We can't thank you enough for accepting our invitation to chat with us today. Thank you very much, everyone.
Yeah, thank you. And there was no fist fight.
Thank you.
That's a good thing.